Hello and welcome everyone to ZaranTech. Data science is an increasingly essential field in today's data-driven world, projected to grow by 15% by 2029, reflecting its growing importance. This field harnesses the power of data to drive insights and decisions, crucial for businesses aiming to remain competitive and innovative. Let us dive into data science master training. Data science is the art of turning raw data into actionable insights. By using various tools, algorithms, and machine learning principles, data science helps analyze vast amounts of data to uncover patterns and trends that inform decision-making. Data science significantly boosts businesses, increasing profits by up to 30%. It's essential for data-driven decisions across all industries. By leveraging data, companies optimize operations, enhance customer experiences, and innovate products. Data science drives decision-making and innovation, helping organizations predict trends, understand consumer behavior, and make informed decisions in a data-rich world. In this course, we will cover the essentials of data science. We'll start with the basics of data analysis, explore different machine learning algorithms, and understand how to visualize data effectively. By the end of this course, you'll have a solid foundation to start your journey in data science. But before we begin, please subscribe to our YouTube channel and hit the bell icon to receive regular updates from us. Now let us look at the agenda. Agenda 1. Statistics. 2. Variable types of statistics. 3. Measures of central tendency. 4. Introduction to R. 5. Python. Let's dive in.
Statistics is actually a procedure of gathering, organizing, analyzing, presenting, and making inference from the data, right? So you go ahead and collect the data, and there will be multiple sources, multiple types of data, right? You kind of organize it and clean it, and you try to make it readable, right? So there are a lot of things you can do in that particular sense. And then you start analyzing it, right, using different statistical techniques that we're going to discuss, right? So you'll start analyzing, and then you actually present it, right? So you cannot analyze everything in the head, right? You have to present it in a way that you can explain, and once you present it in a right manner, you can actually get inference out of the data. Right. So the whole idea of data science is that I can extract insights out of data. Right. So that taking inference out of that particular result is what's the key here. Right. So it's the procedure of doing all these things one after the other is basically statistics. Right. And we have mainly two types here, which is descriptive statistics and inferential statistics. Right. Now, how do we say that? Let's take a simple example. Right. Now, for example, just take revenue of, for example, Amazon. Right. So you want to let's say you have access to all the Amazon data. Right. So they have been tracking data of your transactions and whatever activity you do, and you have the data at hand. Right. So now if you want to understand what's the sales of Amazon from last 1 year, revenue of Amazon from last 1 year, right? You want to visualize it, and you want to see it. How is it growing, or how is it decreasing? How I can see how many customers are enrolling, how many customers are purchasing, how many customers or throwing up comments, right? A lot of things that we can analyze there. So just analyzing or just understanding what happened in the past, right? For example, how much was the revenue, how many customers are there? Just trying to understand at a high level the historical presence of that particular business, right? And that particular understanding is called descriptive statistics, right? So you are just trying to, let's just assume that you are in the current time and you are trying to understand what happened in the past is basically descriptive statistics, right? And in the same way, now that you know what happened in the past, right, you take a step ahead and try to find a reason why it happened, right? For example, let's assume that the revenue is going down, right? And you want to try to go back and try to understand why the revenue is going down, right? So that particular uh, uh, a branch of statistics is basically called inferential statistics, right? And under the inferential, we also have a step ahead, right? Wherein you want to understand, not only understand why it happened, you also want to predict the future as well, right? So that is called as predictive statistics, right? So we have descriptive statistics, we have inferential statistics, and under inferential, I mean, we can create a new category itself, which is predictive statistics, right? Wherein you want to predict the future, right? So those are the three different branches or three different classes or categories under statistics, right? Wherein understanding past, why it happened, and predicting the future is what we are going to do, right? And to do that, we have different techniques or different type of methods that we're going to use, and we will go ahead and see how to do that, right? So before that, I mean, just why use statistics? Just few examples are listed down, right? You want to capture how effective the marketing was, and there are a lot many things, right? So even in the clinical industry, so you want to find out the effectiveness of the drug, right? And in a retail company, you want to find out who are loyal customers, right? So if you just jot it down, you'll get each and like hundreds of applications. Everywhere, wherever there is a data, there is a need of statistics to basically make sense of the data you have, right? So if you are not able to make sense or get insights out of it, there is no point in having data also, right? So that's how your statistics and data comes together using tools like R and Python. You come to a actionable insight with to the business, right? So that's what statistics is at a high level, right? We will get into different variable types and different or types of different tests present in statistics. Before that, I'll take a pause here and open for questions. So any questions here? What are the different types and what is statistics? Why we have to use that? And move ahead to the next topic, right? So one basic thing that we have to keep in mind is the type of variables that we are dealing with, right? Let's say for a business, you have a data set, and it contains multiple types of data, right? For example, just assume there is something called as a transactional data, right, or customer level data, right? For past 1 year, right? So you have all the details or all the transactions done by a customer, right? Okay, this customer bought these many orders and of these many total sales and these many items, and this is the location, and we also have certain demographics details of that customer as well, right? So this is gender of this, is the location of this customer, and just so on and so forth, right? We can have all these details of the customer, right? Now, so if you just imagine now, just imagine this putting it in an Excel, right? So you have all the column names, right? Of his customer name, customer ID, total sales, total number of orders, and his gender, his age, his location. Just imagine in Excel, and you have it for, let's say, some thousand customers, right? So now we can have in that particular table, we can have two types of variables, right? So one is quantitative variables, another is qualitative variables. So it's already there, definition, but can anyone maybe explain what is it? Definition is there on the screen, but I want some different answer or different application. What is what are quantitative variables and what are qualitative variables? These are two different types of variables or data we can have. right? So I just explain the data set. So what are quantitative variables and what are qualitative variables? A definition or an example would do.
Yeah. Quantitative variable is something which keeps on changing as per the time. So just like the blood sugar or blood pressure. So in the entire body, the blood pressure varies at different places and different times and based on the many factors. So that I can say as a quantitative variable, and other one is a qualitative variable. Yeah, I think this is a fixed and it could be like a male and female, so it is a constant.
Perfect. Go ahead. You're correct.
It could be a number. It's based on some scale.
Perfect. Okay. Nice. Okay. Sure. No issues. Perfect. Thanks for that. So yeah, basically quantitative variables, or it's also called numerical variables, right? Which something can be expressed as a number or it can be quantified, right? So I mean, you can take a number and make it as a quantitative. So basically, for example, assume that anything which is quantifiable, right? For example, age, right? And as you told, the blood sugar level, right? So we should be able to quantify that particular variable and say do certain operations on that, right? Do certain numerical operations on that, or any variable which can take the values between -infinity to +infinity. A number can be expressed as a quantitative variable, right? And qualitative variable is, again, as he explained, so it doesn't change with time, right? And it cannot be expressed with a number. It's basically they're already predefined and they have specific values for that, right? And for example, gender or religion, right? Or your place names, it can be your names itself, right? So a lot of things. These are called qualitative variables, right? So I'll just take a simple example and explain it. I mean, I'll ask it as a question maybe. So PIN codes, right, or zip codes, right? It will be like 3, 4, 5, 1, 2, 3, or whatever, like 6 digit or 4 digit, whatever, right? So is PIN code or zip code is a quantitative variable or a qualitative variable? Okay, I'll just ask the question again. Is your PIN code or zip code, right? You have a code for every area, right? And let's say that code can be like 3, 4, 5, 1, 6, 8, something, like random 6-digit number is the zip code, right? So is it a qualitative variable or a quantitative variable?
Qualitative variable.
Okay, one answer is
quantitative.
One is quantitative variable, and I'm expecting 3 answers. I mean, Asta cannot hear us.
Quantitative. Oh.
Okay, quantitative. Okay. Naga?
Qualitative variable.
Qualitative variable.
This variable will not change for the city. So once it is, the city has got one particular zip code, it is going to be the same.
Same. Okay. Evelyn is saying it's qualitative. That's great.
But then qualitative, the data cannot be expressed as a number. So not really sure. I'm thinking quantitative.
Okay. Perfect.
The question did not come well. You were you talking about a city, or you just mentioned some numbers? The question, I didn't get it.
Oh yeah. It's just the numbers. It's just the numbers. Yeah. It's a zip code or a PIN code will be just a number, right? So there won't be any characters mentioned, right? So it's just be a number. Yeah. The answer is it will be a qualitative variable, right? When I say that in the definition, data cannot be expressed as a number, it's not the not exactly the number we are talking. So this we cannot express it as a numerical aspect of that, right? So I think the zip code is basically a categorical variable which is already predefined, which is already fixed, and it's not going to change, and that's why it's qualitative variable. It's just that that particular area we are mentioning with the number, right? We can use any different categorical characters as well, but we are just using numbers for representing that area, and it won't change, right? So basically, a zip code or pin code is a qualitative variable. So how this confusion will have, right? This confusion is expected, and how we will go ahead and clarify that, or to avoid the confusion, what we can think as qualitative variables, we can go ahead and do certain statistical analysis, right? I mean, not statistical analysis, basically numerical analysis. For example, calculating mean, right? Just remember that for a particular variable, if you can go ahead and calculate mean, that will be a quantitative variable, right? For example, age, I can have an average age. For example, blood sugar level, I can have an average blood sugar level, right? So I can do certain mathematical operations on that. So that's your quantitative variables, right? Your qualitative variables are basically, you cannot do anything on that. For example, zip code, right? So you cannot calculate average of zip code, right? Even though it's number, you cannot calculate average of that. You can just only count them, right? So you cannot do any other mathematical operations, right? So that is one thing that you can remember, where quantitative variables are be expressed as number, and they are quantifiable, and we can, as clearly mentioned, it will change with the time, and we can calculate mean, median for that particular variable. We can go ahead and do mathematical operations, right? But qualitative variables are something which cannot be, where we cannot do mathematical operations, and it will be fixed, it will be predefined, and it won't change with the time, right? So just try to remember this, while these small definitions, while identifying whether it's a categorical or numerical, right? Okay, for these are also called categorical and numerical variables. So if I am using multiple names, don't get confused. Categorical and they are also called as numerical variables, right? Quantitative or numerical variables, qualitative or categorical variables. To continue on the same lines, so for these types of variables, we have something called as univariate analysis. I will go ahead and explain that, but I think before going to that, there are three types of statistics, right? Or three types of analysis we can do. Analysis basically, which is univariate, bivariate, and multivariate. So anyone has any idea on this? What is univariate analysis? What is bivariate? And what is multivariate? What is univariate? So in statistics, we have three types of analysis. One is basically univariate analysis. Second is bivariate analysis. Third is multivariate analysis. So anyone knows? I'm just asking, so you, by any chance, you know what is univariate analysis?
I think from the word univariate might be analyzing a single information, while the bi will be analyzing a group of let's say group of information. Some, I don't know how, like group or some different set of information. Analyzing will be the bivariate. That is my little knowledge.
Yeah, studying about only one variable at a time can be considered as a univariate, and just like in case of a treadmill, you always see how much fat you burn or something like that. So in case of a multivariance, you try to add one more parameter to it, like heartbeat.
Uh-huh.
In
Okay.
case of multivariant, so you add more than 2 parameters.
Okay. Okay. Good. I think you were on the right path, right? So univariate analysis is basically dealing with one variables at a time, right? You might have a whole data set where you have 8, 10, 100 variables, but you take one variable at a time and you start analyzing or understanding it, right? That is basically univariate analysis. For example, let's say you have age of all your customers, right? And you want to see what is an average age of the customers you have, what is the median age of them, and what is this standard deviation present in the data, right? So all these are the techniques that can be used and which can be used on only one variable at a time, right? Average age, or as you mentioned, your treadmill ratings, or it can be your blood sugar level again. It can be your revenue. It can be your any variable. Just take one variable and you start to even it can be categorical variable, right? Gender. So basically, you calculate more for that. So we'll go one by one. What are these weapons, or what are these techniques? But you only handle one variable at a time, right? And bivariate analysis is where, as the name suggests, you take two variables at a time, right? So two variable, two features, you take them and try to understand, is there any relationship between the two variables, right? For example, let's say gender and salary. I don't know, I'm just randomly picking, right? Is there any relationship between gender and family? So, sorry, gender and salary. So is salary dependent on the gender, right? I don't know. So that is one relationship that we can find out. And is your age is for your business is age related to the products that he's buying? I don't know, maybe, right? So what I'm trying to do is taking two variables at a time and trying to understand the relationship between them, right? That is your bivariate analysis. So we will use something called as correlation, t-test, chi-square, ANOVA. So there are certain techniques we can use to basically understand that, right? And going ahead, as the name suggests, we have multivariate analysis, wherein you take multiple variables at a time. But how you analyze multiple variables at once, right? So that's why we have something called as dependent variable and independent variables, right? Here, your one output is dependent on a lot of variables, right? For example, your sales of a particular revenue of a particular company is dependent on a lot of other parameters, right, or other variables, right? And you're trying to predict the sales, right? I don't know, some just random thing, right? And you're just trying to predict the house price of a particular house, right? And dependent on a lot of things, right? Where is it located? What is the square feet? How many bedrooms are there? So on and so forth. So what you're trying to do is taking a lot of independent variables and trying to find one dependent variable which is kind of dependent on all these independent variables, right? So this is where your machine learning comes into picture in multivariate analysis, wherein you are trying to predict the dependent variable, right? You are trying to predict that one variable which is dependent on a lot of things, and that is what your multivariate analysis is. Perfect. So that is on that. What we'll do, we'll just start with univariate analysis, right? I think these are the couple of things that we have been studying from our childhood, right? So what is mean, median, mode? What is it? Again, we'll just listen from you guys only. What is mean? What is median? What is mode? We'll go one by one. What is mean?
Mean, I think, is a average of some group of numbers. When you have some group of numbers and you want to find the mean, it means you are trying to find the average of the numbers when you put them together.
Okay. What is median?
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
Median would be from the name when you arrange group of numbers from, let's say, ascending order. The middlemost number when they are the middlemost number. I don't know. I'm just trying to remember.
Correct. Yeah, sure. Go ahead.
Yeah, if you have some set of numbers and you arrange them in order, the middlemost number is termed as a median.
Okay. And what is mode?
Mode basically is, let's say you have a set of numbers. The one that appears most is a modal number. I don't know if I'm correct. I'm just trying to be correct. Sometimes.
You're 100% correct. That's good. Anyone else wants to add any points here?
Why do actually we calculate these values, mean, median, mode?
So why do we? Okay, we will. I will come to that. I'll briefly explain you. But before that, the definition of mean, median, mode. Anyone wants to add anything? So let's just assume that we have a certain set of numbers, right? For example, just the blood pressure numbers, right? Or age, or any sales, or whatever, right? Assume that there is a set of numbers, and we can go ahead and calculate these univariate measures, right? So these are also called as measure of central tendency, because what you are trying to do here is trying to find the center, right? The middle number, right? Or the average number, right? And the first is the mean, which is basically sum of all the numbers divided by total number of instances we have, right? Total number of observations. Sum of all the observations divided by total number of observations, which is basically mean, or which is basically average, right? So that is one thing. And to continuation with that, we have median as well, which is basically you sort all your numbers in the ascending order and or descending order, and you find the middle number basically, right? Let's say you have 15 numbers. Let's say, for example, let's say you have 15 numbers, and whatever is the summit or 8th number is basically your is your median. But if you have 10 numbers where you don't have a middle, so it will be 5 and 6 or your middle numbers, right? So what you do is you basically take the middle numbers and calculate an average for that, right? So that is basically median, where you arrange your numbers and pick a middle number, right? And mode is basically you are just basically counting the frequency of the numbers, right? Or it need not be numbers. It can be mode can be for categorical variables as well, because you are just counting the frequencies, right? So that is your mean, median, mode. I'll just quickly explain a couple of applications, but before that, can anyone explain me what is the disadvantage of mean? So there is one disadvantage of mean. That's why we use median in a lot of places. You can just try to think what could be the disadvantage of mean.
Mean will normalize the results. So this is not widely used, whereas median
Mm-hmm.
is the number which is closer to the actual.
One drawback to that, basically, more than disadvantage, there is a drawback. So what does it do? So it will basically take sum of all the numbers divided by the total number of observations. So what could be the harm here?
If you're simple, you have some values that are not correct, then it can throw off your mean. Would that be?
Yeah. When you say not correct, what is that non-correct value? What could be that non-correct value? We can take an example, maybe in this particular example only. We have systolic blood pressure values. So what is that non-correct value? What could be that non-correct value?
Was not entered properly in the set. Like
So yeah, I think you were really close to the answer. So it's sensitive to outliers, right? When I say outliers, for example, let's just observe that we have the values between here, let's say 100 to 200, right? But let's say there is one value which is 2000, right? Which could be the case or which could not be the case, which might be wrong data entry. It can be of 100 reasons, but we have a number 2000, right? So if you calculate mean for this, the value will be slightly higher than the existing value, right? Maybe 2 up to 200, right? Because of just one value, which is far away from your actual factual numbers, your mean is getting slightly on the wrong side, right? Which is close to 100, right? Which is wrong, right? To avoid that, we will be using median. Even if there is a number which is high or too low or too high, when you sort it, that will have a lesser importance. That will be anyway at the end. We will be picking a center number, and our still a median, still a average or the center number will be reliable, right? It won't be affected by your outliers, right? So this is the disadvantage of mean. That's why we will use median in a lot of scenarios, right? But if you don't have these outliers, if you know that we don't have these outliers, then we can just go ahead and use mean, right? And how do we check that whether the outliers are there or not? That is something we will see in the coming sessions, right? So outliers is a topic in itself, right? What are outliers? How do we find them? How do we treat them? We will see it in the coming sessions. But yeah, this is what is for now, right? Mean, median, and mode. And median is sensitive to outliers, right? Does it make sense? Okay, so now we'll come to the application side of things, right? I mean, why do I have to use mean, median, mode? I mean, what is the use of it, right? So, for example, all your data analysis starts from here, right? So this is called summarizing your data sets or summarizing your data to understand what is there and what is being used, right? So for example, now let's just take again, I'll just use the same data set so that you can imagine and you can connect to that business, right? Is for example the retail data set, right? You have your customer name, you have their sales, you have their what you call number of orders, how many items they have bought, and their location, their gender, and few other demographics, right? Now you want to understand what is the average sales I'm getting from each customer, right? So I want to understand how much of a business each customer is getting to me, right? I don't know, maybe $300, $400 per month, or $1,000 per month. I just want that number to so that I can understand my business well, right? So, okay, each customer is giving me $1,000 per year, right? So that is what I'm going after. That is what my business is giving to me, and the whole decisions which I take will depend on that number, right? If I'm spending to get a customer, if I'm spending more than $1,000 to get him enroll and buy a particular product, that won't make sense, right? Because I'm spending more than what he can give it to me, what he can purchase from me, right? So also we'll try to understand what are the average number of orders he's making, what are the average number of items, the products that he's buying in each order, right? So we can do a whole lot of things, and we can try to understand the whole aspects of that particular data set or the particular business just using your name, right? A lot of companies still are in this stage only. They don't want even go to the inferential and predictive statistics. They just want to understand what happened in the past, and the only way to roll up your data is basically using the basic statistical measures, right? You group by certain things and you just calculate mean, sum, average, maximum, minimum, right? You're just trying to do that. So that is where your univariate analysis comes into play. See, so for every business, right? For every data set, right? You will have all possible data at a granular level, right? So when I say granular level, for example, now you go ahead and transact in Amazon, right? And your each and every item that you bought will be each row here, right? You buy a one item on a particular order, that will be one row. Again, when I say a row, it's an observation there, right? They track each and everything, right? So now that they have all customers' data at a granular level, now they want to understand a bit more about their customers, right? Or the sales, or many aspects of that particular business, right? So now, just assume that they want to understand what is the average. I'll just take a different example maybe now, right? Now, for example, just understand that everyone has their age provided, right? So let's say they have age of, let's say 100, all the customer base they have. Now they want to see what is an average age of their customer base, right? Who are their customer basically, right? They want to understand that, right? Which gender customers are buying more, right? So, okay, I'll just go ahead and take the age column and just calculate the mean. I'll get to know that, okay, let's say it's somewhere around 28, 29, right? So I'll go ahead and say that, okay, my customers are anywhere between 25 to 35, all my middle-aged customers, right? Is because my average age of my whole data set I have is basically 28. So it's all measured. Most of the customers are middle-aged, right? And you go ahead and do a mode on the gender, right? You calculate, or your frequency, you basically group by the gender and see how many males are there and how many females are there. Let's say you get somewhere around 70%, out of 100, 70 are female and 30 are male. So my most of the customers are female, right? So it helps you to get to these small insights about your business or about your data set, right? And which you can use and go ahead and take actions in your upcoming whatever. It can be marketing activities, it can be setting up stores, or it can be setting up a lot of things, right? So you take those actions based on keeping these numbers in your mind, right? So that's why your univariate analysis comes into play, where you're trying to understand each business variable that you can think of, right? It can be demographics details of the customer. It can be your transactional details of the customer. It can be anything. On the same lines, right? Just going ahead with our univariate analysis, we have three more techniques, right? Which is basically range, variance, and standard deviation, right? again, I'll just throw this question back to the audience. Any idea what is range, what is variance, and what is standard deviation?
So range is basically between like a set of value, okay, set of values like A to B is a range.
Okay.
And the variance is basically a difference between two metrics, I would say, the variance.
Is standard deviation part of the things you want us to talk about?
Yeah. Or what is variance? What is standard deviation? Any idea?
The standard deviation is a root, the square root of the variance.
What is variance?
Variance is the average of all. Let's say if you have a data, the average of all the data sets that maybe you have.
Okay, fine. No issue. So we'll just get to the answer, right? Perfect. So fine. So it'll come from the top, right? So now, till now we discussed measure of central tendency, where we wanted to find the center number, right? And going ahead, we will discuss measure of dispersion, right? So when I say dispersion, just want to understand how well the numbers are deviated from the mean. From the center, how the values are dispersed across my rest of the data, right? How my data is deviated from mean, right? So to do that, the first technique is range, right? So what range does is it will basically calculate the maximum minus minimum, right? So 11 is the maximum number and 4 is the minimum number. So your range is basically 7, right? 11 minus 4, 7. So that is your range, right? Which will just basically tell you what is the range of values that I have, right? And it is not much used, right? The most used is the variance or standard deviation, right? So variance is basically, again, it tells you the dispersion of the data, and what it does is it will take each data point from your list of data and take the difference between each point to your mean, right? For example, so for this data, your average is 7.8, right? And it will take each number 7 minus 7.8 plus 9 minus 7.8 plus 8 minus 7.8, and it will square all these differences, right? So 7 minus 7.8 square, and it will go to the next number, take a difference from the mean, square it, right? And divide it by total number of observation minus 1, right? So if you go by the formula, variance is basically summation of xi minus x mean whole square divided by n minus 1, right? Which will kind of give you the variance, which is 6.7, right? So which won't give you an exact insight that you're looking for, right? It's just a variance. You will calculate variance first and then you calculate standard deviation, which will give you an insight. But variance is basically following this formula, right? Since
can you quote some business example where it is used?
Sure. Yeah, I will. Yeah. So I'll just quickly cover this up and I'll come to the application, right? So yeah, sorry, we have got the variance now, but the problem with the variance is that you are squaring each and every difference, which is kind of giving you a not correct value, which is kind of high, right? Because you are squaring the differences every time. To nullify this, what you are going to do is basically take a square root of variance, right? Which is basically standard deviation, right? So now the standard deviation is 2.6, right? So now, this is how the calculation or how it's working in the back end to basically find the standard deviation, basically to understand how how the deviation looks like in a particular data, right? So now, I mean, again, the question comes back to where do I use it, right? How can I use it, right? For example, just take one example, right? Let's say there are two sales users, right? Salesmen, right? Let's just take there are two salesmen who are selling a particular item X, and I'm collecting data for last 30 days for these two sales guys, right? And I'm collecting the data of how many, what is the amount of sales that we are getting, right? For example, from day 1 to 30, the amount of sales he made, right? One day he made 40, 50, 30, 20, 100, 120, or whatever, right? Same like for one guy, and I have the data set for both the guys, right? So now I just calculate the mean first. I just want to understand who is the best sales guy here, right? I want to understand who is making more sales here, or who is the most reliable, right? So to basically decide who is the best salesman, right? Now I'll just go ahead and calculate that, and for salesman 1, right? I'll just write it here, right? For salesman 1, I get a average of let's say 48K dollars, right? This is average he's making, right? And for a month, this is average, and this is for 1, and let's say I have for salesman 2 as well, right? Let's say he's making an average of, let's say, 51K, right? And I have a standard deviation, right, of a $5K, just a second, which is 5K, and comma standard deviation of. So I went ahead and calculated these two metrics. One is the mean or the average sales, another is the standard deviation, right? 25K. So if can someone tell me who is the best salesman here, or the reliable? So best is not only reliable on only one number, right? So it depends on a lot of things. So if you could go ahead and declare who is the best salesman out of these two based on these two metrics, what would you do?
Salesman 1.
Salesman 1. Why is that so?
Why? Because the standard deviation is less, so it's more reliable.
He is more reliable. So when we say standard deviation is less, what does it mean?
So the range the amount of sales he make per day is more consistent. So where the salesman 2, where someday he might sell 0, someday he might sell high value, and the sales are not consistent.
Anyone else? I mean, what about others' opinions? Who is the best salesman?
I think the same actually. I agree with the person who ever explained.
Okay.
So because the standard deviation is less, he's more consistent, basically.
Yes, right. So I think you got the point what I wanted to convey, right? So basically, whenever we decide something, whenever we try to take an action on our historical data, we should not only look into the mean or average, but we should also look into the standard deviation of that data set or that particular variable, right? So if the standard deviation less, which means that the data is not spread across, it's kind of tight packed, and from this application, it shows that it should be tight packed because I don't want variation in my sales, right? I want consistent sales, and if a guy is making $20 a day and $100 another day, there is a high risk that any given day he can make only $20, which is a risk I cannot take, right? If he's interested, of course he can make 100 up to 100, but I'm not worried about that. I want consistent sales. So that's why I will always go ahead with this sale, because I know that he's consistent, he is reliable, and I can go ahead and count on him, right? So that's how this result is interpreted, right? And that's why we need to take care of standard deviation as well, right? This is one simple example, right? And as we solve multiple use cases, that as we solve more projects and multiple use cases, you will get to know more applications. But yeah, this is one way to think from that point of view.
From the slide which you have taken,
yes,
you have compared standard deviation with range and variance. So when I look into the data which is given in your example and the results, so for range it is 7, variance is 0.7, standard deviation is 2.6. So
yes.
when I look at the data here, so when I look at 4, yeah, it is 2.6 away from the average. When
Yes.
when I look at 11, it is 2.6, some change from the 7, or which is so. So why we are learning about range and variance here? Why? Because the topic is measure of dispersion. It's how far it is from the mean or from the average. So when you say range and variance, it looks like they are something like mean or median, something like that, but not the dispersion values. So can you quote some examples where range and variance can give a dispersion values in those examples?
Okay, perfect. So first of all, variance is not is not where we are calculating average or mean. If you just closely observe here, your standard deviation is actually coming from the variance. So your formula for standard deviation is basically square root of variance, which is basically this formula. So what I'm doing here is just putting a square root here because I did a square for every term, which is basically calculating the difference between my mean and squaring it. I'll just have a question in this particular concept itself. Can anyone tell me why there is a square here? Closely observe the formula. Closely observe
Negative values
to negate the negative values. Exactly, right? So it can be negative, it can be positive, and it can be cancelled, and we can get a 0 of variance as 0, right? Which is not correct. That's why I'm just trying to square it of all the differences, and then I'm just adding it and dividing it by a total number of observations, right? So this number, if you want to compare to your mean or to your actual numbers, is not a comparable number, right? Because you are squaring it every time, right? So that's why, to avoid to negate that square root, so I mean the squares, we are taking a square root of that, and then we are using standard deviation to compare with your mean, or to basically come to a conclusion, but not variance. So if you just observe here, I did not use variance, I used standard deviation, right? So that's why variance is also a measure of dispersion, but I'm using standard deviation because I want to remove that square root. I want to remove that square, so that's why I'm using square root and using that for an insight. So technically, your standard deviation is coming from variance, right? So those are not two different things. They are same things, one with a square, another with without a square. Makes sense? You're still confused? Hello?
Yeah, I'm more looking at the examples for range and variance, where exactly they are applicable. I know in this case of example, standard deviation is very well applicable. But
variance is also applicable, is what I'm seeing. So here you can use it as a variance 25. It's the same thing. Is equal to square of that is basically 25. And here your variance will be whatever 625. 625. So these both are same. It's
mathematics.
Hello? Hello?
Hiya. You can go ahead. Sorry.
Yeah. So basically, both are coming from the same. I mean, from the same formula. So there is no difference between variance and standard deviation. But range, I'll tell you why. So basically, again, range is again sensitive to outliers, right? For example, let's say you have a number which is 2000. Sorry, my bad. Right? And now if you calculate range, right? So even your range will be on a higher side, right? Because 2000 minus 4, right? But again, if you closely observe, it's not that distributed because of that one value is distributed, right? So because of that one limitation, we cannot use range, right? That is one way of answering things. The other is it's what you are trying to. I mean, there is no direct application as such, because as I already mentioned in the first, we don't use range anywhere. But it's kind of a dispersion technique where you want to understand the maximum and the minimum, where you will get to know. Okay, for example, let's just take from the same example, right? From this particular example only, right? So I'll just have a range. Just take range as let's say he did a minimum of 25 and a maximum of 75, right? And he did a minimum of 5 and a maximum of 105, right? So if for these values, you will get these kind of measures. And if you want to calculate here, this will be 50. And your range for this particular user is range is equal to 100. Right? So I'm still using the one of the measure of dispersion, which is range, to again come to the same conclusion, right? So here in this case, the dispersion or the range is again less, right? It's just 50. The deviation or the dispersion of his values is maximum minus minimum is just 50, again, which is kind of reliable. And again, salesman here is, salesman 2, 105 minus 5, which is basically 100, again, which is spread across. There are a lot of values between them, and the difference is 100. Again, he is not reliable, right? I'm using the same measure of dispersion technique to again come to the same conclusion, but because of there are certain limitations or drawbacks to range, there are drawbacks to the range, we'll just go ahead and use the standard deviation, right? But the end goal is I'm trying to do the same thing.
I have one more question. So in the previous slide, we learned about mean, median, mode, where mean is not the right way to calculate, and median is the right way to calculate it.
If there are outliers. If there are outliers.
Because there are outliers. So now my question is, in calculating the dispersion, why do we take mean as a reference in this area? So why don't we take the median as a reference?
Okay, we have to take median as a reference if we know that we have outliers. Here the assumption is that we don't have any outliers, or we have treated them, or we have removed them. But if we know that there are outliers, we can use median as well. It's the same thing. Mm-hmm. So what we're trying to do here is when we say mean, we are just trying to take the center number, because what you are trying to do, we are trying to find how the numbers are deviated from the center. It's not exactly mean. We want to understand how the values are deviated from the center. So center, if there are no outliers, mean can be my center. If there are outliers, median can be my center. So yeah, that was pretty much from univariate analysis, where we covered range, variance, and standard deviation, right? All these things we will be implementing in tools like R and Python, mostly in R with a use case, right? But that will be doing a bit later sessions once we cover a couple of concepts here, and once we cover a basic of R, wherein R programming basically, wherein how to do basic things like how to, first of all, how to install it, how to import certain data sets, how to do certain mathematical operations. So once we know how to do all those things, we will come back and do certain assignments or projects on this particular concept. The univariate analysis, I mean, whatever we covered till now and whatever we're going to cover few more things tomorrow, everything will be implemented in R, right, with a certain use case, and wherein, I mean, before that we have to do certain R programming, and that we will be doing in coming sessions, right? So for now, just try to remember or understand what is univariate analysis and what is a measure of central tendency, what is measure of dispersion, and we will come to the implementation in R in incoming sessions. Cool. So that's on that.
What are the skills required to be a very good data scientist? Okay, from based on the statistics and all, I think like if you're good at mathematics, then you can survive very well. Okay, first thing. And apart from that, like, okay, say I'm coming from a SAP background. So, I mean, it's a matter of like, you know, your attitude, like how you learn it and how you practice it. I do agree, but is there any like prerequisites, you know, to learn these courses, data science or data engineering courses?
It's good if you have a bit of exposure to programming knowledge, but that is also not required. So everything will be started from scratch. For example, I'm talking about R programming, right? So that we will start from scratch. As you rightly put, as long as the right attitude is there, I don't think you don't need to have any prerequisites. So all the subjects will be from the scratch. But as on a positive note, if you have programming skills, you can learn faster. If you have a good mathematical background or statistical background, you can learn faster. And if you also have a good domain knowledge, you can learn faster, right? So equally, your business or domain knowledge will come into play. So that's why even MBA people can learn a bit faster because they have a bit of business flavor, right? So all these three things will come together. So if you are good at any of these three things, it becomes a bit faster. Otherwise, you are learning all the three things parallelly. It might take some time, which is when you compare to others, but it's not a prerequisite as such. Okay, so yeah, bivariate analysis, as we discussed, is basically comparison. Basically trying to understand if two variables are dependent or if two variables has any relationships, right? We need to, as we discussed, right? So we can have a categorical variable, right? Categorical, or we can have a numerical variables, right? And let's say you are doing analysis between two numerical variables, right? So for example, there are two numerical variables and you want to understand whether there is any relationship between them, right? For example, let's take age versus salary, right? So is there any relationship between age and the salary? As the age increases, is my salary increases or not, right? So these two are numerical variables, right? And if I want to do an analysis of bivariate, where trying to understand these are related or not, I have to go ahead and do something called as correlationship, right? So there is an analysis called correlation, where you're trying to understand the relationship between two numerical variables, right? Let's say you want to try to understand a relationship between two categorical variables, right? So let's say there are two categorical variables, and you have to understand the relationship between them. For example, let's say gender and gender versus maybe the type of school or something, right? right? So is there any difference between them? I mean, is there any relationship between them, right? So both are categorically you want to try to understand the relationship. So to do this, you have to do something called as chi-square analysis, right? And let's say you have a combination where you want to analyze a categorical variable and a numerical variable, right? For example, take gender versus salary, right? This is categorical, this is numerical, right? Which for this you have to use something called as ANOVA, right? So this, we have two types of variables, and you are just trying to get a combination of each of them, right? And we're understanding what all types of analysis we have to do, right? For a numerical versus numerical, we have to do something called as correlation. Of course, I will explain what is correlation and what is chi-squares in each section, but this is just at a high level, right? If there are two categorical variables, we have to do something called as chi-square analysis. And if we have categorical versus numerical, we have to do something called as ANOVA, right? Right. So this is the key element of bivariate analysis. We have to remember this, right? I mean, at times you know what to do, right? You know that you have to find a relationship between two variables, but you don't know what test to be done, right? What analysis to be done, right? So if you remember this, a lot of things will be easier, right? So if I have two numerical variables, what should I do? I should do correlation analysis. And if I have categorical and categorical, chi-square analysis. If it's categorical and numerical, ANOVA analysis.
All right, let's test your knowledge. Here's a question for you. What is the primary purpose of data cleaning in data science? Option A, to make data visually appealing. Option B, to remove irrelevant data and correct errors. Option C, to encrypt sensitive information. Option D, to compress data for storage. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
So we have statistics and we understand what statistics is. So statistics is broadly classified into descriptive statistics, inferential statistics, and predictive statistics. So in descriptive statistics, we try to answer business problems, or we try to solve business problems just by summarizing the data. Maybe maximum sales gained in last year was in the month of October, which was $500. Minimum sales was in the month of March, which is $50. Your average sales over the year was so and so. So you use mean, median, max, and all of these, probably univariate analysis, what you have learned, to kind of describe from the data. So that's nothing but descriptive statistics. Basically, you try to tell what has happened or what is happening. In inferential statistics, we kind of try to answer why something has happened. Suppose, let's say, I'll take an example. There's a sales data, and inferential statistics, we end up doing a bivariate analysis.
And one more thing, I forgot to mention, as a prerequisite, I want everyone to kind of maintain your own cookbook where you're taking down the notes of whatever has been taught in the class. I might sound like a school teacher, but trust me, that's you're gonna thank me post the course how helpful this note's gonna be. So maybe have your own diary or maybe use any of the notepads, but please make sure you are taking down the notes. So coming back to this example, let's maybe talk about one of the retail company and their sales. So the date, the sales, and probably what was the discount given on that particular date. So 1, 2, 3, 4, 5. Sales was like $50, $70, or 100, 120, 250, and discounts given are like 2%, 7%, 10%, 14%, and 20%. So this is the data I have, just a sample data I'm taking. The data might be of huge. This is like just a 5 days data, right? Now, if I want to apply descriptive statistics, what all I can do? I can say the maximum discounts given by your retail is like 20%. The minimum discount was 2%. And the average discount is, 10%. So on. Even the sales part. Right? Now, coming to inferential statistics, also called as bivariate analysis, wherein we actually do the bivariate analysis to kind of infer something from the data, to kind of see if there is any relationship. Now, do you see, okay, sales on the month of, or probably on the day of 5 is highest, 250. Now your business will ask, your business owner will definitely come and ask to you, hey, why my sales were like too high on that particular day? Can you figure out and tell me why? From the huge data set, you have told them that the sales was higher on this particular day. Now the business owner will ask, can you help me figure out why? At that point of time, you use inferential statistics. Now there might be n number of reasons, there might be n number of columns in the data set. So I'm just taking one example. Let's see if really the discount is impacting sales, right? So if I ask you, since the data is small, you can right away tell the sales was higher in the month, on this particular day because the discounts was also high. It's evident from this data, right? And of course, there might be a number of reasons, but let's restrict to only this particular column what we have. Now, how do we kind of, now if the data is small, looking at this, you're able to tell it. But if the data is like really huge, there are like thousands, lakhs together of rows, how do you kind of, answer this or do this bivariate analysis? So for doing this bivariate analysis, we have 3 statistical tests: correlation, chi-square test, ANOVA. Correlation, chi-square, and ANOVA. These are the 3 tests, 3 pillar of statistics, advanced statistics, which will help you kind of go with an evidence saying, hey, this is the reason why something is happening. Correlation test is used when this is called bivariate analysis because you will be analyzing 2 variables at a time. In univariate analysis, you do analyze only 1 variable at a time. You apply mean median mode on that. In bivariate analysis, you analyze 2 variables together to figure out if there is any relationship. Now, correlation is used when you deal with 2 numerical data. If one of the column is numerical and the other column is numerical, you apply correlation test. If 2 of the columns, 2 of the variables are categorical, you apply chi-square test. If one of the column is numerical and the other column is categorical, you apply ANOVA test. I appreciate response from others as well. Okay. Hope you understand what is numerical variable and what is categorical variable. Continuous and categorical. Okay. So now I have a small question for you guys. Are you up for it? On probably what type of data it is? or is it been already asked? Maybe, let's see. So I have a particular column which is called as area pin code. Maybe your address, area address, and then the pin code, or what you call as zip code, right? Address might be some street name, street number, and all of that here. And in pin code, you would have like 00123, 45321, whatnot. You understand the area pin code, right? The zip code.
Yeah.
Right. Now, can you tell me what kind of data it is? Is it a numerical? Is it a categorical? Is it what? Categorical.
Yeah, because
But I see numbers over here, right? Suppose, let's say I'll take another example. Maybe the sales. So sales is a
numerical.
Yes, numerical.
Gender,
Categorical.
pin code,
Categorical.
jersey number.
Categorical.
Why? I mean, even here I see numbers. Even here I see numbers. Why it's called as categorical?
Yeah.
Sales is
It's already predefined.
Predefined.
Okay.
Sales
Yes,
is,
they are predefined. You cannot change. They cannot be changed. Somebody's pin code cannot be changed. Let's say a country's pin code can never be changed. It defines the country.
Okay.
I see in a different way, like it's numerical, right? Sales and discount. These are like metrics or like measures. Actually, you're measuring something, you know, like my sales, how much?
But for sales, it can change.
Okay. I
Sales
think
can change.
Srinivas is closer to the actual answer. So probably if someone asks you, and trust me, this is the typical interview question, at least what I ask. So, and 90% of the people fail in getting it right. This is where it proves your fundamentals are not strong, right? Maybe the perfect explanation for it would be, I'll just try to extend whatever Srinivas was trying to say. You know, suppose, let's say I'll take a mean of this average. So I can say average sales was so and so. Does that make sense? Average sales is 118.
Yes.
That does make sense, right? Now, if I take an average of this and say average pin code is 1673.4, does that make sense?
No.
No.
Right? Exactly. So yes, logically, yes, or maybe technically you can definitely calculate a mean median mode on this. But does that descriptive statistics make sense logically? No. You cannot infer anything out of it. And that's what even Srinivas was trying to say. These are the metrics. These are the things what we can measure on. Right? So this is the explanation what you are expected to say. Hope it's clear. Right? So now you understand why identifying what kind of data it is important. To apply what test. So once you figure out what kind of column it is, what kind of variable it is, respective test can be applied. Now, in this particular example, what test do you think we can apply?
Correlation.
You can use the
Correlation.
Correlation. Yes,
Yeah.
exactly. Right. Now, how many of you have heard of this word before? Okay. So the best part of correlation is you can apply that on Excel as well. You don't have to learn any programming language. For other tests, yes, you have to, you can implement all this only in R or Python, but correlation can also be shown in Excel as well. So right away, I'll show it to you, and then probably I'll get into the explanation of this. Okay. So now I want to see whether there is a relationship between sales and discount. What I'll do is equal to CO correl. Correl is a function in Excel which will help you to do a correlation test. Select this particular column. Column 1, column 2, enter. I get a value called 0.937. Now, the value of correlation output, also this is called as correlation coefficient. It ranges from -1 to
Please, can you go back?
Sorry, you want me to do this again?
Yes, please.
Okay, so you don't have to necessarily know this. So I'm just showing you because Excel. I'm just showing it in Excel. But anyways, I'll do it again. So is equal to CORREL. Correl is a function in Excel which will help you to do a correlation test. Open the bracket. Select the two arrays. This is one data set, one column. This is the other column. Select two column. Close the bracket and enter. You get a value. This value is called as correlation coefficient. And the value of this can range from -1 to +1. 0 being in middle, it ranges from -1 to +1. If the value are closer to -1 or +1, which means that there is a strong relationship. And if the value is closer to 0, which means that there is no relationship. If the value is closer to +1, which means that there is a strong positive relationship. If the value is closer to -1, which means that there is a strong negative relationship. Now, what is this positive and negative relationship? Any guesses?
Positive will mean that.
Sorry?
Positive will be that one is influenced by the other, and negative will mean that they are not related whatsoever, or something like that.
Okay, so it's pretty simple, right? If the relationship is positive, which means that as one increases, the other is also increasing. The negative means reciprocal, right? Inversely proportional. As one increases, the other decreases. So here, as the discount is increasing, your sales is also increasing. That's why your correlation coefficient is closer to the +1. Okay, now, how correlation works? So there's a formula for it. I don't want to get into mathematical formulas and all of that because we would not be using it at any cost. We have functions. So how we have implemented here, similarly we'll implement in R and Python. It's very simple. But we have to know how it works. So have you heard of variance? I believe you might have heard of it in the previous session. Variance.
Yeah.
Yes.
Yes. What is variance? What is variance?
The variance is a measure of dispersion that describes the relative distance between, excuse me, the data points.
Exactly. Right. Now, what is covariance? Can you extend the same definition for two variables? Okay. So, variance is how much the data is spread across the mean. Now, covariance is how will discount change if sales gets changed by 1 unit? If sales gets changed by 1 unit, how it's impacting the discount? This is nothing but covariance. And your correlation works on covariance. A unit change in sales, what is the impact on discount? This is what we are trying to capture in covariance. And when covariance is extended to unitless value, we call it as correlation. So when you are doing variance, you try to look at how your data is spread at a column level, right? As you mentioned, the definition of standard deviation or variance, you try to look at how your data is spread across the mean. What it defines is how your value are scattered around the mean. When a unit change in value of mean, how your other values are changed. Similarly, when you apply variance on two particular column at a time, You call it as covariance. So covariance is nothing but a unit change in sales. A unit change in sales, what is the impact on discount? How the discount is changing if the sales changes by 1 unit. This is the covariance. This is what we are trying to capture.
For the variance, you used checking the relationship based on the mean. But for the covariance, you say it's two particular variable, and then if one increase, or does it affect the others?
Yes, you got that completely right. So here, when doing at a single individual column level, you try to compare that with a mean. All you're trying to do is look at how the data is varied. What is the variance? But when we're trying to calculate the correlation, first we calculate the covariance, which is nothing but what is the impact on discount if sales gets changed by 1 unit.
How do I say 1 unit in the sense, okay, what does it mean exactly? 250, there are 250 units, it does mean?
Yes. Irrespective of, let's say, I'm talking about dollars here, forget about it. Yeah, so it's a number for me, it's a unit.
Yes.
That's all I consider, that's all, yes.
So means 250 and discount is 20. If 250 changes to, say, 251, and yes, the discount would be 20 changes to something else, like 20.1 or something, right?
Yes.
So that's what we need to calculate this covariance. Then
that's the relationship what we are trying to find out. So, right, how much you are, say if sales increases by a unit, what is the change in the discount? That's what we are trying to capture from covariance. Now I'll just open the presentation to probably walk you through with a formula and all of that, right? Maybe that will probably give you more insights. Yes. So here, if you see, this is the formula, a huge formula, but it's very simple to understand. Here I have two variables, x and y. So summation of x and y minus summation of x multiplied by summation of y, and then taking their square individually and multiplying it. So this is the formula of correlation coefficient, right? But all we want here is, it's a statistical measure to figure out whether what is the strength or relationship between two numerical variables, right? And this is how, if I want to show it in a graphical way, this is how it looks like. Positive correlation, a negative correlation, and no correlation. If you see, there is a positive trend here. This is my x, this is my y. This is my sales, this is my discount. As sales is increasing, the discount is also increasing. This is my discount and this is my sales. As the discount is decreasing, the sales is increasing. This is a negative correlation. And if the data is scattered, then it's no correlation, or there is no relationship. Right? Maybe this is another such example. This is a perfect correlation. As one increases, other increases. Our coefficient value is 1. This is closer to 1, a bit scattered. This is closer to -1, a bit scattered in a negative direction. It's closer to 0 because it's all scattered in a random. There is no relationship. Right? So this is what it does, the correlation. It's a statistical term which helps us to identify if there are any relationship between two numerical variables. Now, an important concept called as causation. Another important interview question. Let's say I'll go to this. I'll probably go back to my Excel. Clear? Now you can go back to your business owner and say, hey, your sales was too high in this particular day because your discounts were high. Yes? So more the discounts you give, better the sales are. This is the insight what I'm going to give to the business owner. Now, I'll give you one more business scenario. Right? Now, what is the business scenario I'm trying to talk? sales of ice cream in San Jose. $240, $300, $400, $500, and so on. I have another column, and let's say 600, 200, and so on. And I have another column, same data set, maybe temperature in Toronto. (2°C), 3, 4, 5, 6, 1. Now I'll apply correlation on this. What's the correlation value? What's the correlation value?
It's a positive actually, 0.98, which is positive. So there is a relationship which exists.
Yes. So can I go back and say to this ice cream parlor that, you know, as the temperature in Toronto increases, your sales are increasing? Yes. Can I say that?
Yes, we can.
Are you sure? How does temperature in Toronto related to the sales of ice cream in San Jose?
Oh, sorry. Yeah. No. These are like two different locations actually. Look, though the figure says 0.98 positive correlation, but logically that is not correct.
Exactly. So this is where, you know, our intuition comes into picture and the statistics fail. Right? So this is what I was trying to say. This is causation. So correlation versus causation. So you don't have to blindly, no, I might have taken a very easy example, right? But there might be cases wherein you have to figure out whether I should really apply correlation on this. Does it make logical sense? Is that really a cause? So that's a difference between correlation and causation. Are you clear? Okay, perfect.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
So you can just go to this slide. Maybe you'll have a better clarity. So these are the few examples what I could think of. Yes, you see a strong relationship, but logically that relationship doesn't make sense. Clear so far?
This figure here, 0.98, that we are talking about, does it mean that it is is it the strength of the correlation, or is it that, okay, it is strongly related?
Yes, it's a value. It says that it's a strength. There's a strong relationship.
Is it the confidence level that we can say?
Kind of, yes. I'm coming to the confidence level. So what we actually call it as p-value. So are you from stats background?
Yes.
Okay. This is not really a confidence level, but this is a correlation coefficient value. A value which is closer to 1, we say there is a strong relationship. This is just a reference value. You cannot use this value anywhere else in your calculation, right? Okay. So in that way, you can consider it as a, anonymous for your confidence interval. I believe that you're master of this correlation chi-square and ANOVA already.
Like I have done it during my master's, like as I had one project as data analytics, but after that I couldn't follow, though I was working in research, but I was more on the commercial side. So I want to go back to the analytical side now.
Okay, perfect. So now, when we have two categorical variables, so can you guys give me one business example of where we have two categorical variables?
Department and age. In each department, say for example, like we have like freshers, or like we have senior staff or something. Based on the age criteria, like we can do kind of some analysis. So there we take basically department and age factor. So
not really. Maybe in terms of business impact. I mean, yes, you're right, but maybe in terms of business impact, which is like, which will help us in analyzing chi-square test. And let's say, maybe I'll give an example. Gender, categorical, male, female. Now, I have another column called as churn. How many of you have heard of this word churn?
No.
A business term, maybe one who has worked closely with the business might have definitely heard this term, churn.
Basically, customer loyalty, something like that. Retention of customer or business.
Exactly, you're right. Okay, if not churn, you guys might have definitely heard of attrition.
Yeah.
Yes. So in HR terms, attrition is been popularly used if some employee would try to leave an organization. That's an attrition for a company. Similarly, for every business, let's say you're a regular customer of Walmart, and someday you realize no, Loblaw is a better retail, or maybe Costco or Target is a better retail, and then you start purchasing from Costco. So you are a churn customer for Walmart. So every company tries to retain a customer. Now we have a data wherein we have already captured whether this particular customer was a churn or not. This is the data, yes or no. 1 means yes, 0 means no. So these two are categorical data. You guys agree with me? Yes. Okay. Now, if you want to figure out if there is any relationship between churn and gender, can you see any relationship looking at this data?
Yes, no, like, okay, the 6 simple rows here, the male attrition is more actually, See, I'm not basically from statistics background, but okay, I just say like whatever comes to my mind.
If I make it, even this is 0. Now it's clearly evident that males are high or prone to churn than females, right? So since this was a small data set, you could clearly kind of figure out and analyze and try to find a relationship between two variables. What if the data is huge? That's wherein you apply chi-square test. We know that correlation works on variance and covariance.
Excuse me.
Yes.
But like since we have only 4 data sets of male and 2 of female, can we still say that?
No. Okay, let's not get into the statistics part of it. I'm just trying to give an example.
Okay.
No. It's a very. I mean, to answer your question, no, we cannot infer anything from a small sample. Never.
Yeah.
You would always have a biased output. So I'm just
yeah.
trying to show you an example. That's all.
Okay.
Right? We know that correlation works on variance and covariance. Now, chi-square test works on frequency. What is frequency?
The number of times something.
Yes. So that's all we try to compute. Calculating chi-square is like pretty simple. It's pretty simple. Just take the count. So I'll just show you. What we create is a contingency table. right? You're able to see the PPT? Yes. So this is how we kind of create the contingency table. Now, if I want to create a contingency table for my data set, how would I create it? Let's do that quickly. So we have gender and churn. Now I'll have gender on one side, and I'll have which is male or female, and I'll have churn on the other side, which is 1 or 0, yes or no. What's the count of gender M versus churn? Can you help me fill this? 2. M0?
It's actually 3.
Sorry, it's a 3. It's a 1.
1.
F1, 0. F0, 2. This is called as contingency table or confusion matrix. So from this is what we compute first. And then you calculate the percentage. So what's the total number of male? 4. And female? 2. This is the total count, right? Now, out of this, what's the attrition rate for or churn rate for male? It's 3 divided by 4. It's 75%. And for female, the attrition rate is 0%, right? So I'm just telling you how this chi-square test works internally. So all you need to do in R or Python is just apply this chi-square test on this particular data set. You would finally get an output, which is a p-value, which is a confidence interval. P-value ranges from 0 to 1. And if a p-value is less than 0.05, if p-value is less than 0.05, you go ahead and say that there exists a relationship between gender and churn. I cannot obviously show you that here because I cannot apply chi-square test on Excel. But in R, once you learn R, we will implement all of the statistics in R. Maybe it will take another 2 to 3 sessions for you to get good hold on R. Post that, we will do all of the statistics in R. Okay, but for you now to understand it theoretically, this is how it works internally. It creates the contingency table and it calculates the percentages of what's male and churn rate versus female churn rate, and the difference is huge. And the count is equally balanced. Here, the count are not equally balanced. If you see, as one of my friend here was trying to mention, we can really apply a statistical test on this. No, you cannot. It's a biased result. Male population is higher than female. It considers all of that and finally computes a p-value. If the p-value is less than 0.05, you say that there is a strong relationship between gender and churn. Now, why this 0.05? How did you arrive at this? What is this 0.05? It's nothing but a confidence interval. So if the value is 0.05, which means that you are 95% confident that there is a relationship between churn and gender. Whatever p-value you get, you just subtract 1 into that, and that's your confidence interval. If the value is, let's say, 0.01 or 0.1, the confidence interval is 90%. And why 95%? Why the cutoff is 0.05? Why not 0.1? It's from the statistical thumb rule, what we call it as. So there are a lot of thumb rules in statistics. Researchers have done a lot of experimentation around this, and they have finally arrived at confidence interval of 95% for all the statistical tests you do. And of course, if there is 94%, you can definitely go ahead and approve it. There's no harm. This is just a thumb rule what we take as a 95% confidence interval, which is 0.05 p-value. So p-value, if you see, which is less than 0.05, which means that there's a strong relationship between these two variables. Maybe I'll give you some time to digest, but make sure you're clear with this, yeah?
For the chi-square method, we do have to create a contingency table.
No, you're not supposed to create it. This is just how it works in the backend. How it computes the frequency. I'm just trying to explain you. All you need to do is, like we did for correlation, right? One line of function. So similarly for this, there is one line of function. You put it on this particular data set, you will get the output, which is p-value. You need not to worry about all of this. This is just I was trying to explain how it works in the backend.
Okay. And this is done by R with R and Python.
Yes, R and Python. Yes. This we will do. We will do all this implementation on real world data set in the coming sessions once you are comfortable with R. So this is going to be our last session on statistics. Next. So okay, maybe I'm not sure if this has been told to you guys how your journey would look like. We will go R and statistics in parallel. 2 sessions on stats. Once we are complete, we'll move on to R. We'll make sure you are really good with R. We will do all the hands-on exercise. Once you're comfortable with R, we will implement all of the statistics in R. And then we'll go into machine learning, advanced statistics journey towards machine learning. Along with Python as a programming language, we'll try to learn Python in parallel. And then we implement all of the machine learning algorithms in Python. And then we'll move on to natural language processing. We'll implement all of the natural language processing in Python. And then we'll move on to deep learning, recommendation systems, all of that. So this is how it looks like. Clear?
Yes.
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 Now, suppose, let's say, I'll bring in another variable, which is called age. Age is 56, 23, 46, 22, 13, and then I have like 60. This is the age of that person. Now, looking at this two, can you guys tell me, is there any relationship between age and churn?
Maybe people on the older side are more prone to churn.
Yes, it's evident. Now, how did you kind of say that? It's very simple, right? Even in chi-square, we looked at the count, and then we said, here, what did you look at?
Like age bracket may be greater than 30, we can.
So basically, if I can explain you, now I'm trying to explain you how ANOVA works in the backend. Okay, again, the output of ANOVA is p-value. Output is still the same. You need not to worry at all. After the test, the output is again thrown as p-value, but I'll just try to explain how it works in the backend. So again, what it does is it kind of creates 2 classes, 1 and 0, churn 1, churn 0. Now it calculates the mean for 2 groups. Here we have 2 groups, yes or no. Whenever it's 1, what is the mean age? So this is 1, this is 1, this is 1. Their mean age is 54, right? If you take a mean of 60, 46, and 56, it's 54. And the mean of 0 group is 19. Right? So from this, don't you think it's clearly evident that the age difference between these 2 groups is huge? So whenever such circumstances happen, your p-value by default will be very less than 0.05. So you say that there's a strong relationship. And of course, you might ask for the formula. I can definitely show you the formula and all of that. But similarly for correlation coefficient. But we are not trying to write some exam wherein you have to calculate all of this. Definitely Python and R are definitely going to help us here. So you need not remember formula at all, but you have to remember how it works. That's really important. Yes, clear with ANOVA? Here it was a numerical variable, here it was a categorical variable. So you applied ANOVA, you have the output, which is again a p-value. So these are the three important tests in bivariate analysis under inferential statistics. Predictive statistics is all about prediction, wherein your machine learning journey starts. Your linear regression, your logistic regression, and so on. Clear? Yes. So this is how statistics looks at a very high level. Now, there is one more concept under statistics, which is called as outlier. What is outlier, according to you guys?
Extreme values.
Can you give me an example?
Like maybe a set of data has the range from 10 to 100, and then we see a number which has the value of 1,000. So that's like, and then like that's like a very extreme value for that data set.
Okay, right. Maybe can you give me an example for age itself? I'll just try to note down them. You tell me some values.
Okay.
Some 5 values.
15, 30, 35, 40, maybe 110.
Okay. Now you are saying that 110 is an outlier.
Yeah.
Now, I'll give you another example. 23, 34, 37, 27, 27, 60. Do you have any outlier here? And suppose, let's say I'll make it as 60, and then I'll make it as another one which is 80, and then I have one value which is 125, and there is another value which is 90. So I have two examples, two ages here. Are there any outliers here? If so, which one is that? Are there any outliers here? And there's another value which is...
If we calculate it with respect to the mean, then maybe 60 is an outlier in that data set. Like if you see like major values are around 30, and then 60 is an outlier.
Anyone else? So outliers can be of two types. One outlier is wherein you know for sure there is no human being whose age is 125. It's definitely a data entry issue. So this is one kind of outlier. The other outlier is what she was trying to mention. It doesn't belong to the group. Yeah, the value might actually be true, but that doesn't belong to the group. With this, the machine learning algorithm gets biased. So these are the two kinds of outlier. Clear?
Yes.
Clear on the outlier concept? And there's another concept called as missing value. I think I don't have to explain what is missing value. And anything, you know, in the real world, none of the data is clean. It's filled with outliers and missing values. So as a part of data cleaning, we treat the outliers and the missing values. So how and all of that we'll see when we are actually implementing it.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
We have completed statistics. In statistics, we have three types of statistics. One is a descriptive statistics, and another one is an inferential statistics, and third one is a predictive analysis or a predictive statistics. So what is descriptive statistics? just you will tell what has happened in the past. You will be having a data set, you will analyze the data set, and you will come up with the insights telling that what has happened in the past. That is what the descriptive stats is. For example, now I am dealing with an Amazon data set. If I tell, and I have a data set of last 1 year worth of data, cool. And if I tell an insights telling that for this particular region, the sale was very low at this particular time. So I'm telling what has happened in the past from the data set. So that is a descriptive statistics. And what is inferential? You're giving a reason why that event has occurred in the past. For example, in some particular region, the sales went very high, right? And because you have given a 50% discount, because of that, the sales went very high. You're telling a reason why that event has occurred or happened in the past. So that is an inferential. And predictive is you're just predicting for the future. Here you use all ML algorithms for the predictions. Here you use just statistics, just do group by, count, and just analyze, take top one and give the insights. Right? So we have 3 kinds of statistics. And next you have 2 kinds of variables again in data set. One is a categorical variable and another one is a continuous variable. What is categorical variable? Can anyone tell me what is categorical variable? So I'm just expecting someone to tell me the answer what is categorical variable. Because already you have attended the previous 2 sessions.
It's a predefined variable where the value is already predefined in gender
correct,
can be
correct. Those kind of variable are categorical variable, wherein you have categories in that particular column. For example, I have a column name called gender, and I have values male and female in that column. I have 2 categories, one is male and another one is female. For example, if I have a column called days, in that I have Sunday, Monday, Tuesday, in that I'll be having 7 categories. Right? These kind of variable are called categorical variable, wherein you cannot perform any arithmetic operation on that particular variable. You cannot even find out what is mean, what is median, all those things. What is minimum value, maximum value in these kind of variables. Cool. Those kind of variables are called categorical variable. Next one is a continuous variable, wherein you have numbers or values or a numerical value present in that. For example, salary. His salary is something like $500, $700. You have numbers in it, and you can find out the you can perform any arithmetic operations on this particular variable. You can find out the minimum value, you can find out the maximum value, you can find out the mean. So if you can perform any arithmetic operations on some particular variable, then it is a continuous variable. If not, it's a categorical variable. Now I have a question. I have a variable called churn. Churn means he is still taking my subscription. Assume that this is a telecom giant and he is taking my subscription. If he is taking my subscription, then it is 0. And I have 0, 0, and I have 1, 1, 0, 1 values. 1 indicates he has churned out. from taking the subscription. So this is a definition of this particular variable. So what kind of variable is this? Whether it's a categorical or it's a numerical?
Numerical.
Categorical.
Exactly, it's a categorical. So here the values are represented in a binary fashion. It is in 0 and 1. That doesn't mean that it's a numerical data. Instead of no, 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 and yes, yes, I have represented it as 0 and 1. Even in this case also, I have two categories in it. Right? It's a categorical variable. Clear? Next, you have a univariate analysis. You have learnt a univariate analysis. You have learnt a bivariate analysis. In univariate analysis, you will just find out a mean, median, mode, minimum value and maximum value. What is univariate analysis? Just analyzing on a single variable is called a univariate analysis. And what is bivariate analysis? If you are analyzing two variables at a time, then it's a bivariate analysis. Or if you want to find a relationship between the two variables, if you want to find the relationship between gender as well as churn, you have two columns. So I treat column as a variables. I call it as column name as a variables. Okay, with this data science fashion. So if I want to find out the relationship between the two variables, then I'll go for bivariate analysis. Again, in bivariate analysis, you have three types. One is chi-square test. Another one is a correlation. And another one is an ANOVA test. What is chi-square test? If you want to know the relationship between two categorical variables, then you perform chi-square test. And if you want to know the relationship between two numerical variables, for example, age and salary, if you want to know the relationship between those two, then you perform correlation. If you have one numerical data column, and if you want to know the relationship with other categorical column, if one is numerical and if another is categorical, then you go and perform an ANOVA test. And you guys know how chi-square, correlation, and ANOVA test works. It was already discussed in the previous session. I'm just giving you a brief explanation or a just revision kind of. Next, you have learned missing values and you have learned outliers. Right? So these are the topics we have covered in the last session, correct? So just guys, I just want to have an interaction session. So it's clear. We can move on to the next topic, today's topic, that is R, programming. R is a programming language used for a data science purpose or a data analytics purpose. So if you want to do a descriptive stats or an inferential stats, you don't need of any programming language or any tool like R. So you can also do it in Excel. So what is the drawback of Excel? There must be some drawback of Excel, because of that the R came into consideration, right? So in Excel, you can have only 10 lakh rows. If you have more than 10 lakhs observation, then Excel fails to load the data. In the real time, you have more than 10 lakhs data. Minimum, you will be dealing with billion, million data sets. So R supports any number of observations in your data set. So that is the drawback of Excel. So we go to R. So what is R? R is a tool, data science tool you can call it as, or you can call it as a programming language. And it was designed by, or it is designed by Ross and Robert. So both of their names starts with R. So they have kept this tool name as an R. And R is a case sensitive. May please make a note of it. R is a case sensitive. And R has more than 1 lakh functions and more than 40,000, libraries it has. It has lot of inbuilt functions and lot of libraries present in R, which make us to code very easily. Directly use those functions which are defined in the libraries. You will see it in the later. It has a lot of functions and libraries present in that.
You were saying that R has one. Is it lab? That word I didn't get it.
So
something
it has more than 1 lakh functions.
Lab or what? What's that word?
Yes, 1 lakh. R has more than 1 lakh functions predefined, and it has more than 40,000 libraries. So,
okay, cool.
It's like 0.1 million.
Yes, exactly. 0.1 million.
Okay, lakh function. Okay.
So I'll just tell you what is that. So for example, now you want to add 2 numbers. I'll just tell you what is functions and libraries. Cool. So now you want to add 2 numbers. You have to write a code for that. So how will you write a code? You will first initialize. I'm just writing. First, what you will do? You will initialize A is equal to 4, B is equal to 5, and what you will do next? You will write result. Result is equal to A plus B, and then you will write print result, and you will take print result, and you will get an output as 9. Right? This is a simple code I've written in C. Or else, if you want to create a function, how will you create a function? Function A comma B I am taking, and I'm writing C is equal to A plus B, and I'm returning the C. Return C. That means it will add these 2 numbers. Instead of writing this, I'm writing it in a function. So in R, what they have done is, we have a function called predefined. This is my one function. They have defined it already. So in there, if you want to add 2 numbers, we have function name called sum, and give any 2 numbers in the bracket, 10, 20. So you will get an output as 30. Instead of writing a logic, I am using a function which have been defined by someone. So I don't need to code. I don't need to write a logic for that. I'm just using a function. So that makes my work easier. So it has such lot of functions. Even to build a model, I'll write one function name and I'll give some parameter my model is. Any machine learning model as such. Clear? So any of these functions will be defined in some or the other libraries. That's it. First, you have to call that library, then this function would be enabled. Clear? It's like, you know, first you have to log in to buy some product, right? In the same fashion, in any e-commerce website, you have to log in to buy some product. In the same fashion, you have to first install this library, and then you can use the functions defined in that package. Some functions would be defined in some or the other libraries. In one library, you will be having 5 to 6 functions. Cool.
Are there any compulsory libraries which you have to import?
No. Yes, you have to know. While learning R programming, you will learn all those libraries. Cool.
Okay.
Yes. In coming, like in another 20 to 30 minutes, you will be learning one library. Okay. So the main topic next is important topic. It's data structures in R. So we have 4 data structures in R. One is a vector. Another one is a matrix. Third one is a list. Fourth one is a data frame. So what is vector, what is matrix, what is list, and what is data frame? So you have to keep these 4 in mind. This is very, very important data structures present in R. So what is vector? Vector has sequence of similar elements. These are called vectors. I'll just show you the slide. In data structures, you have 4. One is vector, matrix, list, and data frame. In vector, what is the definition? It's a sequence of similar data elements. That means if you want to store 1, 2, 3, 4 in a particular variable, you can store in a variable. I'm defining A as my variable and I'm storing all this 4 in a particular variable called A. You cannot mix character here. It should have a similar data type. You cannot mix character or a string or a numeric data to a one variable. You can create another variable wherein it has all character A, B, C, D. That's fine. You cannot mix one here again. That is a vector. And next is a matrix. It is same as vector, but it has 2 dimensions. So this is a matrix which has row and column 1, 2, 3, 4, 5, 6. Again, it has 2 dimensions. It has rows and column kind of thing, and it should also have a similar data element. One metric can be of only numeric and another metric only can be of character A, B, C, D. You cannot mix together. That is a matrix. And what is a list? A collection of these objects or a variable is called a list. Now I have created one vector and I have stored it in a variable called A, or I'll call it as an object. And I have created another P, and I have created another metric called C. If I store all this, then it is a list. And data frame is a rows and columns where we deal a lot of time with the data frame. I'll show you what is data frame. So this is a data frame which consists of rows and columns. We deal a lot of times or all the times with this data frame. Yes, take as this. It has rows and it has columns. Order ID is my one column, status is my another column. If you have column name and values in it, then it's a data frame.
Is it like a table? Can
Correct.
we say
Table, Excel, any CSV file, Excel,
okay?
anything. It's a data frame. So now I'm hoping you guys have installed R in your local machine. Cool. So what you do is just open Google Chrome, write download R, and just click on the very first link and just click on this download R. I'm just clicking on that. So I'm getting a file downloaded here down. I'm just canceling it. So please download this and let me know once you guys done with this. So once you're done, you have to again download or install our IDE. So once you do this, once you install this, again go to Google, say download RStudio. And just click on the first link, download RStudio, and just download this. I'm just clicking on that. Download for Windows. I'm doing. If at all it's a Mac, just do it for a Mac, and just I'm canceling it. So just let me know once you guys install both R as well as RStudio. Perfect. So that it's the latest version, 3 point. It's the latest version you have to download. Once you Google it, you will be showing your recommendation of a latest version itself. Download the latest version, whatever it is showing.
We need to download the R and the RStudio.
Correct.
Right?
Correct. And then we'll start off first how to create a vector, how to create a matrix. First we'll start how to print hello world initially. Then we'll see how to create a vector, then how to create a matrix, and goes on. Clear? So just let me know once you guys download this R and RStudio both. Okay guys, I'm just giving you a time. Just let me know once you guys complete it so that I can continue the session.
So basically, see, I just downloaded the zip file, and that's my system is a Windows system. And normally we should see the kind of setup options, but I don't see anything. Okay, I see the zip file, so I just unzipped it, which is R 3.6.2, and which is config.
Have you opened the zip file?
Yeah, I opened it actually. I extracted it to this one, a normal file, normal folder, and I see different folders and some config stuff. Which
Yes.
one? Yeah.
You open the folder. Open one of the folders. You should have an EX file. It should be an EX file to install. .exe. Maybe you should see that in RStudio.
Okay, 1 second. I see different folders called DOC, ETC, M4, PO, Share, SRC, Tests and Tools. And beneath that, I see some files. Okay, just files. Site file, AC file, in file, FW.
Hey, Srinivas, you're just facing an issue to download R and RStudio?
No. I downloaded R. I got a zip file. Okay, I just unzipped it. It obviously unzipped into a folder. When I go inside that folder, normally we see, whenever we do like this kind of things, we see a kind of .exe or like setup file, right?
Correct, exe file.
Yeah, but I don't see any exe file in my folder.
Then you have downloaded a wrong thing, I guess. Just re-download it again. There is no file which have been downloaded like a exe file.
Okay, so I simply just typed download R, okay, in Google, and I see the R project for statistical computing. I think this is a website.
So one second, what I'll do is I'll just unshare my screen, share your screen so that I'll guide you. So when you guys install R and RStudio both, just go to your search bar, then just type R. You'll get RStudio app, this symbol. Just click on that. Within a few seconds, it will open you this window. This is what the R tool is. Correct. Perfect. So RStudio has split up into 4 windows. This is the first window. This one is a second window. This one is a third window. And this one is a fourth window. First window is a scripting window wherein you write all your codes in this window. This is your console window. Here, when you execute some of the lines, here the output will be shown here. That is a console window wherein you get to see the output of the code executed. And this,
I'm seeing 3 windows in my own. I don't know if that is okay.
You're only seeing 3 windows. Okay.
I see the console, the
Just
environment.
click on this. Write R script. You will get another window.
How to search actually? Okay, it is installed actually both R and RStudio. It seems like.
Go to search.
Yes.
Just type R. You got this?
No, I haven't actually. I typed it already. R.
RStudio you do. STUDIO.
Yeah, I think yes, I can see now. Yeah.
Just click on that.
Yeah.
Yes. Okay. So this is a console window. This is a script window. And this is an environment window wherein whatever you store in some objects that will be shown here. So if I want, I'll execute this. One second. I'm executing this. So my string got saved here in an environment. Right? All the variables or all the object will be stored in an environment. And this fourth window is a plot window wherein if you plot some graphs, bar plot, pie chart, histogram, line graph, that will be shown here. And you have help also. And you get to know what all packages are present. These many packages are present in R. You can make use of this. So it's kind of a help and a plot visualization sector. Okay. So first, now I want to print hello world. Okay. So what I am doing is first, so everyone got the script window, right?
No, I'm still not getting the script window.
Okay. So below file, you have a plus symbol. Just click on that and just click on R script.
Okay. Okay, I have it now.
Yep. One more was. So everyone got the page, right?
Yes.
Okay, perfect. So now, first thing, I want to store some of the words or some of the string or some of the characters and print those characters. How do you do it in R? First, I'm doing is I'm writing hello world in a quotes and I am storing it in a variable called my string. You can call it as whatever you want. And this is a precedence symbol. No need of using that. You can also use is equal to. You can use that as well as is equal to. Whatever is handy with you guys, you can use that. here what I'm doing, I'm just pushing out this hello world into a variable or an object called my string. So once I type this and keep cursor on the line wherever you want and just enter, control plus enter. Just press control plus enter. Next, what I'm doing is I'm just doing print of variable. Now my string holds hello world. If I do print of my string, it will print whatever is present in this object. If I do again control enter, see, I got an output that is hello world. Again, here, it's not necessary that you have to mention print. You can just directly type the object name or a variable name, then do control enter. Again, your output will be shown. It's not necessary to write a print over there. Clear? So I want you guys to execute these two lines. Now, I'll give you 2 minutes. Just print hello world in R. Unable to establish connection with R session. Okay, just close this session. Yes, R studio you close. Okay, just write A is equal to in quotes hide. Just write. I'm not sure why you're getting this every time. Now just write. It's control enter. Yes. No, you will not get an output. That is connection is not establishing. To run the code, you have to enter control enter. You have to press control enter to run the code.
In my case, it is saying that error in print. My string. Okay, object my string not found.
Yep, exactly. So what you have done is you have not run that third line. First you have to run that, then you have to run this.
Okay. So let me do control enter.
Control enter. Correct. See, now you can see in environment my string have come.
Yes.
Now you do print my string. Correct.
Yes, it is.
Now you got an output. So it's not necessary to write a print also. You can remove that print. Just mention variable name or just mention object. My string, you will get an output. So this is how you will print some statement in R. Wait for a second. I think your system is slow. For some time it will give again, it cannot establish connection with session R.
Is this a common problem?
No, it's not common problem. Okay, you do one thing. Come down in console. Just right there. A is equal to. Just do control enter. Don't select. Just do control enter. That's fine. No need of selecting. Let me know once you complete this. Okay. So this is how you display in R. Next, if you want to know the type of your variable.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
There is a method. Again, I'm using a function here, class of my string. it will give you the data type of that. It tells me it is in a character format. The data type is a character. So whatever I have stored here, it is in a character data type. To know what type of data type is present in this object, then you have to use class. So just code it. I'm going slow so that you are coding it parallelly. Just type class and give your object name. It gives you the data type of that object. It is a character. With the help of class function, you will get to know the data type of an object. Now you want to make all the characters in a caps. So for that, what I am doing is I'm just writing using a toUpper method or a function. With the help of toUpper, I can change everything to an uppercase, and I am storing it in a variable called result. If I run this, control enter. So changing to upper, whatever I have mentioned is now all in uppercase. Now, if you want to do it for my string, then just give here your my string. Hello world is in all caps now. toUpper will help me to do all capital letters, and I am storing it in a result again. The same fashion, we have toLower as a method. If you want, you can do it for this particular text, or you can do it for my string, whatever you have executed. So now you guys know how to store some sentences or some text, or how to display some text in R, and how to make all the characters in capital letters or else in lowercase. And you guys know how to see a data type of an object. Next, we'll see how to create a data structures in R. You guys know we have 4 data structures in R. One is vector, matrix, list, and data frame. And you also know all 4 definitions. Now, how to perform it in R, we'll see it. Now, what I'm doing here is I'm creating a variable called v. Whatever want you can create it. You can name it. V is equal to C of. We should read it as vector of. C of. You should read it as vector of. And these are all my numbers. So this is vector of. This C pushes all these values into a variable called v, whatever you name it as. So this C is pushing all these values into a created variable. So this is how you create a vector. Control enter. So v, you can see here it got saved. Next, if I do print v, control enter, 1 2 3 5 6 7 8 9. So this is how you create a vector. Vector is created using a C operator. C operator helps us to push the mentioned values in the bracket. Again, what is vector? You cannot put character in it. You cannot put like this. it should have a sequence data element, similar data elements. I'm getting all the outputs, all the numbers present in that vector. So in vector, you can perform sum. If you do sum of V, control enter, you'll get a 41.
So I did B, 1, 2, 3, 4, 5.
Exactly. 1 second. Just go to 8th line.
Please, just go ahead.
8th line.
8th line, okay, I'm here.
Yes, you have not executed this. First execute that line. Control enter.
Okay. Okay.
Now you do control enter.
Why we have to execute every time, the values also?
Yes, because, yes, exactly. So why we have to execute is, before execute, this R is designed a line by line fashion. So if you have not executed this line, that means the vector have not been created at all still. How can you perform, how can you print V? First you have to run this, then only you can run this, right?
Another programming language, normally we write all the piece of code. Okay.
In that case, what you do? You just select all these things and
yes,
then you shift enter. Control enter, sorry. Getting?
Okay.
So if I select this, then I'll do control enter, everything will be fine.
Okay, I think I got it, yeah.
So here they have given us an opportunity to run line by line also. Next, you can perform sum of that vector, or you can, and there is another way of representing a vector also. C of sequence is another method. 1, it starts from 1, creating a vector, and it ends till 20, and the difference between each value would be 5. So this is, now I have created a vector, I'm printing it. So it started from 1 and it has taken till 20 and the difference is 5. This is how you can create a vector using a sequence method. Here I'm using a sequence method. I want to, now the problem statement is I want to create a vector which starts from 1 and ends till 20, and the difference between each value should be 5. In that case, you have a sequence method. I'm giving a starting number from which the vector should start, and 20 is an endpoint, and 5 is a parameter wherein you give a difference, how much difference you want. So once you execute that, this is your vector. Cool. Next.
Very good, thank you.
Yep. Next, I have created a vector which consists of character. You can also try out that. Exactly. This is what I meant. It has 3 parameters in a sequence function. First would be the start value, second would be the end value, and third would be the difference between value. Exactly. You can create a vectors which consists only of character also. You can just try out. Just let me know once you guys done with that also.
What is this vector underscore char function? Vector sequence, I understood.
No. This is just whatever you want, you can name it.
Okay.
This is just I am naming. You can do whatever you want. You can just write E also. Some value, correct. I have stored this thing into some variable name. Some name you can give. You can take your name also. That's fine. So just let me know once you guys create a vector for the character.
You can't mix up the characters, right? Like maybe character numbers, like data types. It has to be like consistent when creating vectors.
No, you cannot mix. That is what the definition of vector is. Vector is a sequence of similar data elements.
This sequence function works only for the 1 to 3, I mean numeric, right?
I think it will work for a character. Just try it once. I'm not sure. I'm just trying it even. It will not happen actually, because
Yeah,
sequence is for only for numbers. It will not happen. Okay. So we have like another method to create a vector also. Now I want to create a vector from 1 to 100. Right? In that case, I cannot write all 1 to 100 numbers with a comma separated. Right? There should be a way to represent it. So for that, we have 1:5. So vector underscore sequence. If you write vector underscore sequence, I'll just create one for you guys. W is equal to C of 1:5. So from 1 to 5, all numbers got stored in a variable called W. So you can also do all numbers.
R is like a case sensitive, right? I just
Yes,
tried with
R is a case sensitive. You cannot, if you have stored a vector in a variable like small w, then you have to mention small w. You cannot write capital W. It will tell that W is not defined, not found.
Not only for the variables, even for the C, that function.
Yes, exactly. Everywhere. See how to create a matrix. So you guys know what is the definition of matrix? That is a two-dimensional array of a similar data elements. Again, here we have a method called matrix, and you have a C. I'm using a vector to push values into a matrix. With the help of vector, I am pushing all these 6 values, and I am mentioning the metric has a parameter. First parameter would accept all the numbers what you want to display on matrix. Next parameter would be how many rows you want, and next parameter would be how many columns you want. Once you run this, the matrix got filled. It has 2 rows and 3 columns. And make sure that this matrix will fill in such a way that it first fills all vertical first. 1, 2. First all vertical rows will be filled, and then it goes to next column, and it goes to another column. If you want 1, 2, 3, 4, 5, 6, then you have to give it in this fashion: 1, 3, or 2, like that you have to give it. You can see now, 1 has come here, 2 has come here. If you want 3, you have to give 3 here again. In that fashion, it fills. Any doubts in creating a matrix? And to be frank, nowhere these vectors, these metrics, these lists are used in any real-time use cases. Just you should know, but to clear an interview, to know this, it is very important. You should know data structures, but in real time, in data science, we are not going to use all those things. Next is a list. Lists is a collection of different objects. You guys know what are objects now? Objects are these. Matt, these are all the objects.
Is it also since to n row is equal to 2? Okay, I did not give that spaces on either side of the.
That's fine. That's fine. So here you have to make your intelligence and specify n rows and columns. With these 2 rows and 3 columns, the values will not fit in. Because of that, it is showing you an error. It got executed, right? Next, you write mat. Just to control enter, you'll get an output. Correct? Okay. The C should be inside one bracket, right there. Execute now. Okay, there should be comma after bracket, 6 bracket, there should be a comma. Yes, there you do a comma. Yes, now you run it. Yes. So this is how you create a vector as well as a metric. Next, we're gonna see what is list. List is a collection of different objects. You guys know what are objects now. So whatever you're giving the name, you're storing it. Those are all objects or variables. Whenever I call variable or an object, I meant this one. Whatever you define, whatever you store. Okay. So what I'm doing is I'm using a list. Here also don't confuse. I'm just writing list. List is equal to list of. First, I have defined it as vector, I guess. Okay, it's not there. Vector is not there. V. So mat is there. Varchar is vector is also there. See, I have executed. Yes, I have executed now. Right. So this is how you create a list. So if I press Control Enter, it got stored in a variable or an object called list. If I do Control Enter now, you can see all the outputs are shown out. See, first one is, first I have defined V. V ka output, I got it. Next, matrix. Next, yeah. So all the output of objects will be shown in one list. That's it. It's a collection of objects. Simple. It can be matrix, it can be vector. In vector, it can be any data type, it can be a character, it can be numeric. Anything can be stored in a list. Clear? You can execute this and just let me know once you guys done with that. Next thing is a very important one. So next is a very important thing. For example, if someone asks you to create a data frame, most of the times we don't create a data frame, to be frank, because we will get the data from a client. We are not gonna create our own data set. Now, if I want to predict something, I have to ask data for that, right? If I want to predict whether the person will leave this organization or not, so for that organization, from that organization, I should get a data set. I should get a table, right? So we work on data frame. So if someone asks to create their own data frame, we have a method called data.frame. Data.frame will help us to create rows and columns. So this is my column name, gender, and I am making use of vector and I am pushing the values. Next column is height, and making use of vector and pushing the respective heights. Weight, age, and I'm closing the bracket. So I'll just run Control Enter. So it got executed. I'm just print to PMI. So now you can see this is your data set. Gender, I have male, female, and the height is this, weight is this, age is this. This is a data set. This is how you create a data frame in R.
But can you go over again, please? I'm sorry. Can you go over again?
Sure, sure. If you want to create a data frame in R, if you want to create a data set in R, this is how you create. You use a method called data.frame. Will help us to create a data frame. And the first here is your column name. You're giving open bracket, then give the column name is equal to push the values for that particular column using vector, comma. Next, I'm naming a new column name and I'm pushing all these respective heights to the variable called height, comma. Next weight, next age. So I have created 4 columns with 3 rows each. And if you do control enter, that will be executed. If you want to see the data set, just do BMI or just give the name, whatever you have given it here. Else you give print of that. This is how you create a vector. I mean, not sorry, vector, a data frame in R. Clear?
So you just do print BMI and it will come.
Yes.
Yeah.
Just.
But are you going to enter the first all the things that you have added up before?
Just do control. Just write BMI. That's also fine. No need of print.
Okay, so I'm saying that after you have entered the gender, the height, the weight, and the age,
okay,
you don't execute. Do you have to execute before you come and do the BMI execute
yes,
again?
Yes, correct. You have to execute this whole thing before running this.
Oh, so you select all and execute.
Yes, yes. Select or else anywhere. Keep cursor anywhere and just do control enter. It takes everything. Now you guys know how to create a data frame, but in real time you will get the data, right? And you want to import that data to R to work on that, right? Now I have this CSV, I got this data set from a client. Assume that I got this data set. Yes, I got this data set from client. Now I want to work on this. Now I want to do analysis, I want to build a model and stuff. You know how to create a data set in R, but I want to import this. So even you will learn how to import this data set into this R in the next code. Before that, we have some few methods. If you type ls bracket, it tells you what all variables are present in your directory. That means what all objects have been stored in a environment. It will give you the list. Next is
when you say environment, it is like the present file. I mean, present.
Present. Correct. If you want to delete some of the variable or an object, you have a method called rm. So rm bmi, it got deleted. Now BMI is not there. If I write now BMI, it will tell me no object is found. For that, again, I have to run this. And again, if I run BMI, it will give you an output. It is already stored now. How many times I click BMI, it will show me an output. If you remove it once, it is gone. Again, you have to execute that code.
So this RM is removed.
Yes, exactly. Next, if you want to know the working directory of your R, now you are coding. So what is your working directory? If you want to know, for that you have get wd as a method. Do control enter. So right now I am working in this location. but I don't want to work in this location. I want to change my location. Then you have set WD and give path whatever you want. And then just to control enter. I don't know what's the problem. We cannot change it. It's telling you can change that. So now you are working in that particular directory, in your folder file, in your local machine where you are working. Now you have created a code here now. Now I have created a code and this file will be saved in that directory. So whatever you do will get reflected to that particular directory. Give it 5 minutes, you will understand a bit clear. When I'm importing a file, you will get to know. And next, I was talking about packages. If you want to install packages, this is so okay, fine. We'll take this in the next class when we are using deployer package. Okay. Before that, we'll just see how to import a file. Now, I want this order sales data underscore 01 CSV. I have this data set. I want to import that data set to R. You guys know how to create a data set in R. You guys know now using data.frame. In real time, we are not creating a data. We are just importing that data. So, okay, I have sent 2 data sets. So give him 2 to 3 minutes. He'll upload it onto a portal. Just download that CSV files from the portal. So he'll upload the CSV files onto the portal. Just download those CSV files so that you can import that data set into R. So I'll just tell you to import a data set. We have a method called read.csv and give the file name. If this file is present in the working directory where you are working, if this file is present in this working in this directory, then I can directly take the file name. If not, I have to give a path before file name, because we'll just install the package whenever we are using that. We'll use because this select function, I'll just explain you right away. The select function, whatever we are performing here, is defined in a package called deployer. Getting? Because of that, we have to first install that package and then we can use that functions. That will be enabled. Select, filter, sort, all these options are, all these functions are available in a deployer package. And whatever functions we were using here, this 2 upper, 2 lower, these are not defined in any of the packages. These are all basic functions. This read.csv is also a function. It is not defined in any package. It is openly we can use that method without installing any libraries. But these select functions, filter function, subset function, these are defined in a package called deployer. First, we have to install that. Tomorrow we'll see that. So before that, I'm just showing how to import a CSV file.
Okay. Packages are like libraries, right?
Correct. Exactly. Yes.
Okay.
So once we read this file, then this order data will act as a table, right?
Correct. Exactly.
And
so you will just get to see all those things now once you import that data set. So this method is nothing but it tells you the list of variables you have in this current location, in this current workbook. So previously I have all these my string, result, These all are variables have been executed, result, vec_char. If you want to see how many of such are there, then you do just ls of bracket. It will show you everything, what all variables you have, what all objects you have.
You mean in the after we have created the data frame?
No,
right?
no, after not data frame, this is separate one only. This is nowhere related to this one.
Oh.
This is nowhere related to that. Here also it will show you BMI have been created. Here you can see if I create it.
Yeah, I understand that. To find which variables are we looking for? Like, is it the name of the variable?
Yes, it's the name of the variable we are looking for. So, for example, now you have imported 3 to 4 tables.
Yeah.
In real-time use case, you will not get all the data set in a one table. You will get 4 to 5. You have to import that first. All 4 to 5 you have to merge, and all those things you have to do it, right?
Yeah, correct.
So again, for that, you have, if you have imported all the 5 tables, now you want to know whether it, like, how many tables I have imported. You do ls, you'll get to know all the 5 names of the table.
Oh, I see. I understand.
Right. In the future classes, you will get to know. Tomorrow you will be clear. Today you'll be a bit confused. Tomorrow you will be clear. Once we import a data set and we start analyzing data, you will be very, very clear, I'm sure.
When you're using the ls, the list, to find variables, when you have like several projects you're doing, you understand? If you have like 2 or 3 projects, and you kind of have variables for this project, variables for that project, for the other project, will it list everything, or
yes,
if only, or if you have different like tabs? If you
everything, whatever you have created a variable, everything will be listed out.
Is it for each tab? Do you understand? Is it for each tab?
Each
tab,
understand, wherever you give is equal to, there it will be, that will be shown out.
Okay.
So this will be shown, this will be shown, because you are creating a variable. No, this will be shown, this will be shown, again this will be shown, this will be shown, if you have executed.
All right, let's test your knowledge. Here's a question for you. Which of the following is not a common programming language used in data science? Option A, Python. Option B, R. Option C, SQL. Option D, COBOL. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
So now the types of data structures present in R. First one is a vector. Second one is a matrix. Third one is a list. Fourth is a data frame. And also we have seen how vectors are implemented in R, also how matrix, list, and how data frame is also implemented in R. Now, if you have CSV file in hand, if you have a data set in hand, now you want to import that data set into R. How will you import it? So for that, we have a method or a function called read.csv. This read.csv will help us to pull the data set from the local machine. So if your file is present in the current working directory where you are working right now, then it is sufficient to give the file name. Just file name is enough to import the CSV file. If you're working in some directory and the file is in another directory, then you have to go and give the specific path. So now I'm just checking where my order sales file is. So I'm just checking it over here. It's in, okay. What I'm doing is I'm going to the path where the file is. So the file is here. What I do is I'll copy the entire path, Control C, and I'll just go and paste it here, Control V. Okay. Now this file is imported. Okay. So remember, this backward slash has to be changed with the forward slash. All backward slash has to be changed with the forward slash. Now, order data, I'm importing order sales data 1 CSV into an object or a table called order data. So first, everyone import first table and just let me know once you guys complete with that. Meanwhile, I'll be importing the second table as well. Yes. Both the table have been imported. So I'm expecting you guys to import both the tables into R. And just let me know once you guys complete with this task. So if someone asks, how do you import a CSV file in R? So you should tell, I use read.csv to import any CSV files, to import any data sets. So just import 2 files and just let me know. So you are able to import the files, right?
Yeah, basically, like I used the same commands what you said, and I can order and status on the right hand side pane, the global environment beneath.
Yes, yes. Now, yes, exactly. It's done. It's done. Perfect. So others, I'm waiting for your completion. Once you're done with the importing thing, then I can move. So everyone done? So guys, just let me know yes or no. But I'm just assuming like everyone have imported the 2 CSV files. And next, we'll see some operations on that CSV.
So can I verify if it's imported or not?
How will you get to know? So on the right side, you should get this, your table name. It has to be stored in an environment window. If that is done, that the importing is done. Okay. So you just write order underscore data there itself. Order underscore data. Just write and do control enter. Right? No. Write order underscore data. Do control enter.
Yes, I did. Control enter.
No, it's not showing. Okay, just scroll up your environment window. I don't think so. The file got. So can you please move your script window? Okay. Here, just after 01, put .csv. .csv and whole thing in a quotes. Yes, whole in a quotes.
Whole path in a quote.
Yes, yes, whole, correct. Remove one code. You have given two codes there.
It's one code in here.
No, down. Yep, give one. Yes. First go up and execute one.
There's a equal to, I think we need to pull off that equal to, isn't it?
Yeah, yes. CSV is equal to yes. You have to pull that.
That read.csv, then we have equal to symbol. So that
yes, don't put that equal to.
Yeah, we should not have that symbol.
What's equal to?
After read.csv, you have given an equal to symbol. Just remove that equal to. Correct. Now execute both. First execute one, next execute. Yes, next one.
Execute both again?
I mean control enter. Just do control enter. Press control enter.
I did press and control enter.
Okay, it's like it is telling me no file or a directory. So the file is not present in the directory what you have mentioned here.
So whether we need to do a complete statement selection, right? When we press that control enter.
Yes, go to the go to this, the file where you have downloaded. I just want to see that file. Okay, go up. Okay, yes, copy. Yes, now copy, control C. Yes, this is the thing. You have missed that order sales over there. Go to R. After don't do anything. After order sales, you just put another // after order sales, not first order sales. Yes, there you put / and take one back, that white space. You remove one white space. No. Right, order sales now. Order sales. ORDER. Yes. ALES. Yes, perfect. So same way do it for this also. Take a white space back. Now yes. Run it now. No, go first. Go to the first line and run it. Correct. Now run it. Control enter. That's fine. Yes. Now you can see the order data table in a global environment. Next also run. Yep. Yes. Now both files have been imported. Got it? Import the data set. Now you have to analyze the data. First, you have to understand the data. So for that, now first, once you import data, first what you do is you just check how many rows and columns are present in data set. To check how many rows and columns are present in data set, you have DIM as a method. So this DIM will help us to know how many rows and columns are present in my data set. So DIM method, and this is your table name. So once I press control enter, it will tell me it has 8399 rows and 21 columns. 21 variables I have and 8399 observations I have. But next, if you want to check how many rows are present in data set, then nrow is a function If you execute, it tells you how many rows are present in the data set. N column will tell you how many columns are present in my data set. Same way, you can check it for this test status data as well. And also, if you want to look into the table, you have a function called view of do order data. I'm just doing control enter. So this is a table. It has 8399 observations and it has 21 columns. Okay, view is a command to see the complete table. Ncall is a command to see how many columns are present. Nrow will help us to know how many rows are present. Dimension, DIM, helps us to know both rows and columns present in the data set. So just perform these 4 operations and let me know once you guys done with this. And also test with the another table which you have imported, that's a status underscore data. Just check rows, columns, and dimension for that particular table as well. Okay. So just let me know, guys, once you guys complete with this task. So in real time, you get the data. First thing, what you do, you just import the data set and then you'll perform all these operations. If you want to know how many rows and columns are present, this is a command. And if you want to view the table, view is a command. Next, we'll see what all things are there. Okay, cool. So next, we have a command called str. This helps us to find out the internal structure of data set. That means which column has which data type. Now, if I execute this, these many columns I have a column name called row ID. Row ID has a data type of integer. Order ID has a data type of integer. And order date has a data type of factor. That means string. Factor, wherever you see factor, then that is a string. Again, order quantity is a integer. Sales is a number. Ship mode is a factor. Again, wherever you see factor, that type of variable is a categorical variable. This we have discussed in a very first class. Right? While discussing the statistics, we came across, we have 2 types of variables. One is a categorical variable and another one is a numerical variable. What is numerical variable? Wherein you can perform any arithmetic operation. Those kind of variable are called numerical data. Categorical, it has categories or classes in it. Even yesterday also we have discussed on that, right? So factor, it's a categorical variable. Again, number. So here, str helps us to find out the data types present in each column. Okay, so just execute str and let me know once you guys done with that. In the real time, you'll be dealing with lakhs, millions together of data. 30 millions, 40 millions. So if you do a view command, it takes more than 30-40 minutes to open a file because it will be having a huge number of observations. So for that, we have a method called head. If you do head of table name, it gives you first 6 rows which are present in your data set. I'll do control enter. So first 6 rows will be shown to me. Order ID, row ID, order date, order priority, all columns, 6 rows will be shown. First 6 rows present in the data set. If you want to restrict for something, you have another parameter, comma, n equal to 20. So first 20 rows will be shown.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
By default, if you don't give this parameter, it will show you 6. If you want to mention, then you have n is equal to 20, so that you can look out how your table looks like. If your data set is huge, you cannot even view the table. So if you want to have a look into the table, in that case, you have to do a head of table. Head shows you first 6 rows or how many observations you specify here in the second parameter. And another option you have tail. In that case, it shows you bottom 5 rows. If you give n is equal to 5, bottom 5 rows it shows. If you don't give this parameter, by default, bottom 6 rows will be shown to you. So just execute this and let me know once you guys complete that. Now you guys know what is a univariate analysis. We have studied this in statistics. So can someone define what is univariate analysis?
Yeah. Before going there, okay. In this command, right? Okay. When I don't give any, like n is equal to 2 or 3 or something, I don't give anything.
Correct.
Says right. Head order data, and I get like 6 rows. Okay.
Correct.
And I see 3 columns. Okay. Container, product container, base margin, and ship date. Okay. 3 columns and 6 records. Perfectly all right. But when I give head order data, n is equal to 2. I want to see only 2 rows from the top. Okay. Then
yes,
what is
you can do.
What it is actually okay. Maybe it is actually giving the product content in the first line itself. Oh, that's the reason I'm confused. I was thinking why it is pulling off that first column. Product container is not shown like in the first case. Without that n parameter, it was showing all 3 columns next to each other. Yeah, it is showing. Yeah, I'm fine. I think, but the way it is displaying is different. Actually,
yeah. The way it is displaying, yes, exactly. It's not proper. Yes, I understand. Yep. So, can anyone tell me what is a univariate analysis?
When we are analyzing a single maybe like category or
correct.
Okay.
Correct, exactly. Analyzing or doing an operations on a single variable is a univariate analysis. That variable can be of numeric data or it can be a categorical data, right? Numeric, it is a continuous. I'll call it as numeric. Okay, cool. So if at all it is a numeric, what operations you do? What operations you do on a single variable if that variable is a continuous variable? If at all it is a numerical data, then we perform mean, we find out the maximum value, we find out the minimum value. So these are all the things you find out in a univariate analysis, if at all it is a continuous variable. Mean mode. Yes, mode, mean, maximum value and minimum value. Mode is a frequency. If at all it's a categorical variable, then we take out of frequency. How many times, if I have a column name called gender, in that case, the values would be male and female. I'll take a mode of that particular variable called gender to see how many of them are male and how many of them are female. Getting? So to do that, we have a method called summary. Summary of table. If you do this, control enter, it gives you a univariate analysis output. In order priority, it is a categorical variable. It is giving me a count. Critical has 160, it counts. High has 178, and order quantity. People have ordered minimum quantity 1, average quantity is 25, and maximum quantity is 50. Everything you will get it in a one single command, that is summary. Please make a note of it. How do you find out the univariate? How do you do a univariate analysis in R? That is a summary. What is univariate analysis? It is analyzing on a single variable or doing operations on a single variable, whether it can be a categorical or it can be a numerical. So we were discussing about a univariate analysis, doing it in R. Hey, what you can do is, we have just completed 4 to 5 topics. First, we have imported the CSV file. Next, we have studied 4 to 5 commands. After that, you can just please go through the recordings. So, guys, summary, you guys understood, right?
Median mean for each of the variable in the
correct
data set, right?
Correct. And also it gives mode if at all the variable is of categorical. So just perform summary and let me know once you guys done with that. Just ping me, guys, once you execute a summary command. Okay, fine. So now the summary is done. So now, if you want to find out only a mean for a particular column, summary does. Now you want to perform, now you want to find out the mean for a particular column. How will you do it? Summary will find out everything which is present in the complete data. Now, if you want to find out only a mean for a single column, then mean, then you have order data is your table name and sales is your column name. That means you're calculating mean of sales column. This is your table name. This dollar indicates this sale is a variable name, and first left side of dollar is a table name. That means sale is present in a table called order data. R is not intelligent enough. If you mention only mean of sales, R is not intelligent enough to find out whether this sale is present in order data or status data or MAT. It doesn't know in which table sales column is there. So for that, you have to mention first the table name and then mention dollar and give column name. So if you execute this, you will get a mean of sales. Same way, you will execute variance, standard deviation, minimum value, everything separately instead of using summary also. Summary will give you everything separately for each variable you can use. Cool? Clear? Just execute these commands. Okay, perfect. Perfect. Next is, if you want to see only the column names present in the data set. Then you have a function called call names. So all the column names will be shown. Also, there is an alternative called names. This also helps you. Two methods. Try out with this. Try out with this and just let me know. You guys done? Shall I move forward? Okay. Now, if you want to change your column name, if I want to replace order.id column name with a new name, with some other name I want to replace. So to do that, we have a method called rename. So this rename method or a function is defined in a package called reshape or a library called reshape. First, you have to install that library. How to install the library? So here, to install a library, there is a method called install.packages. So I'm just doing install.packages reshape. Just do control enter after this. I'm not executing this because this is a one-time activity. Very initially, you have to install the packages. It is a one-time activity. Once you install any of the packages, if you're using those packages, just you have to call that packages using library function. So now I'm just calling that, control enter. I'm just calling that and I'm renaming. So if I see names of my data now, you can see order date has been replaced with a new name. So this is how you rename your column name, making use of rename method, which is defined in a library or a package called reshape. Installing is always a one-time activity, but whenever you are using a method which are present in those libraries, you have to call using a library. Simple. Clear? Just rename any one of the column and just let me know once you guys done with it. Rename anything. Take region and make it as your name, something else.
So you renaming order ID in that one?
Yeah, anything is fine. Change order ID, anything is fine. It's just, we are learning how to do things in R. That's
It's actually my package installation has failed.
Got failed.
This is like installer packages, right? Package.
Yes.
Installer packages. Okay, once I press this, it is giving R2 is required to build R package, but is not currently installed. Please download and install the appropriate version of R2 before proceeding. The same package.
Unpack. Okay, fine. That is done. Do library. Library of and go up. Execute up. Yes. Library of that reshape. Control enter. Perfect. It's done.
Okay.
Got installed. So just rename any one of the column. So guys, once you rename any one of the column name, just let me know so that I'll move to further topics.
Please, can I ask a question? I'm late, but if I could get you right now, if you do names into my data, it's going to change the names into my data, right?
Yes.
Order underscore data, right? Then silo order ID. Okay, order.
Order ID is the old name. What name you want to replace? This is with what you want to replace. This is what you want to replace with what you want to replace. First, you have to run install.packages. Run it now. Wait for a minute. It is installing it. Error in installing packages. Permission denied. It is not getting installed. You're getting a permission denied. It should get installed. Okay. How have you downloaded this R? Doubt now. Because of that, it is failing. So, do library once. Press Control Enter now. It is not installed. Okay. One solution is like one more time you have to install R. Okay. So just listen to the session. So take down all the codes. If it is not running, it's fine. After re-downloading the R, it will be all right. Next, I want you guys to install this dplyr package. And just let me know once it is done. Install it and call that dplyr using library.
See my data, and I gave the symbol rename order data. See order ID is equal to new name.
Perfect.
Okay.
Yes, I'll tell you. So what we are doing or you are doing is you're just making a change and putting it in a new table called my data. Right.
Okay.
And you're checking it for an old table, old data or order data.
Okay.
So now you have a two copy. One is order data and another one is my data. In my data, there is a reflected change column name, and old one is the same one. Got it?
I got it.
Yeah. So I'll just summarize what all we have discussed. So we have started with R, and in that R we have seen a brief introduction of R and some disadvantages of Excel. And next we have seen the data structures in R. We have 4 data structures, and we have seen the definition of each and how to implement those in R. Next, we have seen how to import a data set in R. That's what a read.csv method does. And how to see first 5 rows, first 10 rows, bottom 5 rows, bottom 10 rows. How to see only column names present in the data set. How to see internal structure present in the data set. How to do a univariate analysis. How to find out the mean, median, SD, standard deviation, variance, minimum value. And also we have seen how to change the column name of in the data set. And we have seen how to see rows and columns present in the data set. And also we have seen how to check the table. That's a view command. So next we were moving out for a dplyr package. In dplyr package, we will learn how to subset the data, how to select. Now, for example, you have 100 columns. You want to select only 2 columns. How will you select those? And next we will learn how to subset. Now you want to have department having only value IT, like filter. We'll do it. These all are defined in a package called dplyr. Next, if you want to sort it in ascending order, descending order, if you want to create a new variable, all those things we will learn it in the future. And also we'll also see an important concept, how to merge 2 tables. Right now we have imported 2 tables. One is order data and one is status data, right? But how to merge those 2 tables, we'll see. That's perfect. Sounds good.
All right, let's test your knowledge. Here's a question for you. Which type of plot is best suited for visualizing the distribution of a continuous variable? Option A, bar chart. Option B, histogram. Option C, pie chart. Option D, scatter plot. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. type the correct answer in the comment section. Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
What is vector? A vector is a sequence of similar data elements. It is a two-dimensional. It is same as vector. Vector is a sequence of similar data elements. Matrix is a two-dimensional, and it should also have a similar data elements in it. Next is a list. List is set of collection. It's a collection of objects or of variables, you can call. Each object can be of any data type, right? And data frame consists of rows and columns. And we have seen the implementation of all these four in R. How to implement vector, and we have seen multiple operations can be done on vectors. You can add vectors, you can subtract, you can multiply, all the things, operations we have performed on vectors. And then we have seen how to create a matrix, how to create a list, and how to create a data frame. Next, we have seen how to import a data set. In a real time, you will get a data set from a client. If you want to work on that data set, if you want to work on R, you have to first put that data set into this R, and then you can work on that data set. So how to import that data set, we have seen. For that, there is a function called read.csv will help us to import the data set. So we have seen how to import the data set as well. I'm just showing you. Yes, this is how we import it, right? And next, we have seen how to see the number of rows and columns present in the data set. And then we have seen how to see the internal data types. And then we have seen how to rename the column names, and also how to do a univariate analysis, that is a summary command. And then we have seen how to see the column names, and also how to see first 5 rows or first n number of rows and last n number of tail. And we have seen how to find out mean for one particular column present in that data set, just to see the names of your columns, and how to rename your column name. Next, I have asked you to install a deployer package. Hope everyone have done that. So these are the topics we have covered in the last session. So today we'll just see how to do a manipulations using a deployer package. First, I'm assuming you guys have installed the deployer package. So this is how you install any of the package. Install.packages, and you give the package name, that is deployer. So once you install, I'm just calling that library. Okay, I'm just calling this. So everyone call that library. Just do Control Enter. So in a real time, if you have 50, 60 number of columns or of variables, out of 50 columns, if you want to select some particular columns, how you gonna do that? So to select some particular columns, you have a select function which is defined in a deployer package or a deployer library, you can call it as. This function is defined in this. That is the reason I am calling a deployer library first, so that what all functions are defined in that deployer library will be enabled. So here, now the select function is enabled because I have called this. So what I am doing is I'm using a select function and I am using a table name. So what is table name? You have read that CSV and stored it in some object, right? That is your table name. And from that data set, what all columns you want to select, you can give it here. So can you guys try it and let me know once you execute this code? This is how you select a particular columns from your data set. I'm just importing the data set once again. Just give me a second. I'll just import the data set because I have to do it once again. This is not in a working directory because I have closed this R tool. So the session went off. So that is the reason I'm just importing the data set once again. Data set is imported, and the second data set I'm just importing it once again. It's done. Yes, here I'm using a select function to select particular columns from order data. So once I do control enter, orders data select. You can see here only 2 variables have been stored. Only columns it got selected. So you want to select. So for an example, I have selected selection using a select function. Cool. This is how you select a required columns from your data set. Guys, it's done. Clear?
I did, but it did not show.
So what you have done is you have created a variable called order underscore data underscore select, correct? Any variable you can give it is equal to you're giving a select operation and order data, order ID, and order date. Perfect. So okay, it is still running. Your command is still running. How you can get to know is, see there you have in console command you have a red circle, right? So that indicates it is still running. So if you click that, it will stop. Just click that.
The one my thing is on.
So your voice is not clear. I'm not able to hear you.
Is it this one? The stop, the red button.
Yeah. Yep. R is not responding. There is an error while running it.
Yeah. That's a command.
There's an error. Close it. Yes, close it and reopen once.
Akash, like that order data select equal to, he used equal to, but he used some less than symbol and then hyphen. Is that causing any problem?
Where he has used
order data select is equal to, we used is equal to.
Yeah, that's fine. Is equal to is fine.
Okay, because
this you can use this symbol as well as is equal to, both are same. That's fine. No. That. So there is nothing wrong in the code. The code is correct. There is some problem with the tool, R tool. It got terminated. So now, execute this. Or it is telling object order ID not found. Okay. So the O is capital, I guess. in the initial class, I have told that R is a case sensitive. So you should give the column name exactly what is present in the data set. So for that, you do names of order, names of your order data, names of your table name. Just do names. Yes, write names. No, not there. In the new line.
In the new line, okay.
Yeah, in the new line, write names of NAMES. Not off. It's off in the sense open and close bracket. Yes, open the bracket. Open bracket. Yes, there you give your table name. What's your table name? Give that.
That means I have to go back to that.
Table name is your order data, right? Order underscore data is your table name.
Yeah.
Yep. Give that inside names.
I'm using the data set that you gave, the ones that you downloaded. That is what I'm doing.
Correct. So that you have stored it in a table called order underscore data, right?
Yes.
Yes. So names of order underscore data. Just do control enter now. Execute this line.
Okay.
Yes. Here you got all your column names present in the data set. So see your order ID. O is caps. Order ID. Change O to caps.
The order ID.
Correct. Else you just copy that and paste it here. That is also fine. Yes. Same to order date.
So do I do
name also caps?
Order ID. Do I do names?
No. Don't do names. Why are you doing names here? It's not required.
Okay.
So just change order date name also. Why I have done names is just to see how the naming convention has been done for the column names. Even see D is also caps over there. D is also caps. Change it to caps D. Yep. Now you run that. Now you click on that order data underscore select. Go to environment table, third window of your R. Yes.
Where should I go?
Third window. Environment table.
Okay. Okay, I'm here.
Yes. There. Select order data select. Click on that. Click on order data select.
Okay.
No, not here. Go up, not here. Go up. Yes, there only you have order data select, right? Third. Yes. Click on that. No, not there. Click on order data select. Yes.
That's
see,
what I clicked on.
now you can see there are two columns which are stored in your table name called order data select, right?
Yeah.
Okay, right. This is what we wrote right today. Prior to that, even like when I say, for example, actually,
I'm just seeing this and no. What you're showing, I'm not able to see it properly.
I'm showing this R window, R Studio.
Yes, I'm able to see your R window, but I'm seeing your dimension of order data.
My question is,
now I'm able to see the select query. Correct.
Yeah, this order data select order data, order ID, order date. Okay. And when I press control enter, it is giving could not find the function select. Okay.
Correct. So you have not run the library called deployer. I'm just guessing.
Okay.
Because that is yes. Now you run this. So order data is not found. That means you have not run the table. You have not imported the data set still. Go to that read.csv and re-import it. Import it once again. Yep. Import both the files. Both you run it.
Yeah, it is okay. Okay, we have to do it every time. Okay.
Every time you have to do because you have closed the session.
Okay. So now if I come here.
So once you close the session, the environment will erase. So now you run it.
So what I said is order data says select these 3 columns, but where I see those.
Yep. Go to environment window.
Okay.
So there you can see order data select is your table name. Second one.
Okay. Okay.
Correct.
Okay.
So just click on that. See, you can see 2 names have been selected.
But I mentioned only 2 fields, order ID and order date. Okay, fine. Yeah, I understood.
First one is your table name. From which table it has to select.
Yes.
Correct?
Yeah.
Perfect. Now, next function is a subset function, or you can call it as a filter function. So now, subset is a filter. Now, you have a data set. I'm selecting an order ID. Now, I have an order priority as a column or a variable. Now, I just want to filter the order priority which has only low value. I am filtering it out. Just give me the table which has only low priority value. That means I want only first row, and wherever order priority is low, I want that row. So if you want to filter your table, then you have an option called or a function called subset. Now what I'm doing is I'm just creating one variable. You can create any variable and subset of your data set. Give your data set name. I'm making use of the same data what we are using, and I am doing order dot priority is equal to, I'm just giving high. I just want the rows which have order priority is equal to high. So once I run this, okay, order priority is not found. That means I think fish is captures.
Yes. What sign is that? Is it equal to high, or what sign is that?
This one. Yes. This one you're asking, right? This one is equal to. Order priority is equal to. 2 times you have to press equal to. That is what the operator will check for a filter. So here, if you see, only high values present in an order priority. See, only high values. I've filtered out high priority rows. So this is how you do it. So just let me know, guys, once you do it. So whatever names I'm giving it here, you can give whatever you want. I'm just assigning it. Okay, just let me know once you guys complete this subset.
What's exactly the subset? Like, what does it do? What effect does it do? What effect does it have?
That is what it will just filter out. Sorry?
Like, do you mean deletes?
It not deletes. It selects. It selects only the value of order priority which is having high.
Is it same thing as the select function too? Like the previous one we did? what's the difference between select and subset? Do you understand what I'm saying? Like, what's the difference between, select also is like selecting particular rows, right? Other data, other ID, and other dates. Why subset is also like selecting technically, right?
Technically, like it selects the order priority which is high. Technically, it is right. It selects fine, but it selects one particular value. So if you're giving order priority is equal to high, it will select only the order priority which has value high, and it will store it in some variable, whatever variable you give. It is like filtering it out. It filters whatever value you give. In SQL, it is like where column name is equal to you give some particular value, right? Same like where condition, it filters it out. So now next, if you want to filter or if you want to give two conditions, you want order priority. Control C, I'm just Control C, Control V. Okay. Here, I'm just giving two things. I'll just see once sales. Fine. Okay, and sales, what I'm doing is I'm giving condition as greater than 200. So I just want the rows which has order priority is equal to high, and also sales should be graded. I want only those rows from the data set. Here I was giving only one condition. Here I'm giving multiple conditions. You can give multiple condition and also filter the data. So here you can see order priority will be high everywhere because I'm filtering it out only for high priority, and the sales, where the sales is, yes, the sales value here, the sales value will be obviously greater than 200 because I have given a condition it should be greater than 200. So you can try out with your own example. Okay, so you can give multiple condition to subset your data set. So guys, just let me know once you guys complete with this. So I'm hoping you have covered these two executions. Just complete these two executions. So that doesn't mean that you have to filter out. I have filtered it for high, you can do it for low. That's fine. If I have given it here RTVAL, don't give the same name. You can change the name. Here also I'm just giving an info. That doesn't mean that you should also give your variable name as info. Okay, just understand the concepts. So this is how you subset a data set. From this session, initially we started with select option. Now you guys know how to select the columns from the data set and how to filter the columns, how to filter the rows. So just let me know guys once you do with this. So now you guys are clear with how to perform a filter on any of the data set. So there is another method to do the same. There is another method called filter. Even that helps us to filter the data. So in this case, again, this filter method is defined in a dplyr package. So you can use subset, either you can use filter. So if you want, see here I have given order priority is equal to low. So that the priority which has a value low will be stored in this table. Here I have given greater than 30. So I just want the rows which have order quantity greater than 30. So this line of code will help us to do so. It gives the rows which has only order quantity which are having greater than 30. So again, here also you can give multiple conditions. These two were a single conditions, right? Here you can have given a multiple condition saying using a comma. There, if you are using subset, you are using an ampersand. Here you are using a comma. It should, the order quantity should be greater than 30 and order priority should be low. Only those rows will be given to you. Clear? So I want you guys to do it and just let me know once it is done. So it is this also do the same thing what subset does for us, but this is another alternative method. That's it. You can try out with this method as well. So guys, just let me know once you complete with select, subset and filter. So we have covered these three topics. So just let me know once it is done. First, we have done how to select a particular columns or required columns from the data set. And then we have seen how to filter the data set. For filtering the data, we have two methods. One is a subset, another one is a filter. Next concept is if you want to sort the data, if you want to arrange your data set in an ascending order or a descending order. Now, here I have an order quantity data, right? I have an order quantity column. Now I want to arrange this in an ascending order or in a descending order. So for that, you have a function called arrange. Again, this is defined in a package called dplyr or a library called dplyr. I'm just giving you first parameter again. It's a table name on which table this column is there. That's what. So on order quantity, you have to perform a sorting. So if I run this, control enter, order data look. This is the one. So here you can see it got arranged in an ascending order. So by default, it will arrange in an ascending order. Okay. If you want in a descending order, then you have a parameter called another parameter which will help you. Now it got arranged in a descending order. First, you can see all order quantities are having a value 50, which is a greatest one. So it got arranged in a descending order. So if you want to be in a descending order, you have to give descending DESC bracket column name, or you can give ascending also here. If you don't give anything by default, it gives you in an ascending order. Clear? So see 1 1 1. So just let me know guys once you do sorting. You can perform on sales as well. If you want, you can do it on sales. doesn't mean that you have to do it on whatever column I'm telling. I'm just showing you how to perform or how to do it in this programming language. You can do it on any of the variant. Because while you guys are sharing the screen, I'm seeing whatever name I'm giving as a table name, you guys also mentioning the same name. Don't do that. Just learn the method and just try to do it yourself and explore things. Because just let me know once the sorting is done. Okay, cool, fine. So the next topic is, if you want to create a new variable, how do you do it? Now, I have a table here and I want to create, assume that there is a no sales column present in the data set. Assume. And you want to find out the total sales. They have given you the order quantity as well as unit price, right? So, and they have given the shipping cost. So this plus this into order quantity will be your sales, right? So now you want to create a new column by multiplying unit price and quantity. Assume only two columns. 1.48 into 1 would be my sale. If this is a 3 quantity and the unit, he has taken a 3 quantity and the unit price of that particular product is $2.08. That is 2.08 into 3 will be my sales, total sales, right? So I want to create a total sales column, multiplying those two columns. So if you want to create a new column, for that, you have a function called mutate. So mutate, give your table name, and this is your new column name or a variable name. And you do order quantity into unit price. It will multiply for the each row and gets saved in a variable called sales underscore new. So once I run this, control enter. So I have an order data new. Where is that? Okay, it's here. So once I click on this, on the last or very last column is a column which I have created. So these are the values. So I want you guys to create a new variable. Create a new variable and just let me know once it is done. So guys, just ping me once you are finished with it. Don't wait for others. Just ping it so that we can cover all the topics very soon and start off with machine learning. We have not even started a machine learning still. Initially, we have completed stats and then we have started an R programming. Today is your 5th session. Just make it soon so that we'll just start off with a machine learning concepts.
Please, what sign is this? Is it a star or?
Sorry?
The sign. Is it a star? Unit, the unit price, the quantity star unit price, this one.
Yes, this star indicates you're doing a multiplication.
Okay.
This you're multiplying order quantity to a unit price. If you put plus, it does a addition. In this scenario, I have to multiply 2 columns to get a total sales, right? That is the reason I am multiplying 2 columns.
Okay, but here, okay, we are telling the table name is order data and sales
Correct.
is equal to order quantity. The field name itself is order quantity.
Yeah. See,
Okay.
you can see here the
Yeah.
field name is
Okay, dots. Okay, I got it. I understand. Maybe. Yeah,
it's an order quantity.
Yeah, I understand.
Yep. Okay. So I'm multiplying this with unit price.
Please, can you create your own name instead of the sales, like a new name?
Yeah, you can do it. Anything, whatever you want, you can do. Give your own name. That's fine. I'm just creating yes. That's fine. I'm just giving now total sales. That's cool. That's fair enough. So you can see now it will be total sales last. In this, it is not there. See, now it got saved with a variable name called total sales. Yeah, perfect. So what you have, so just go down. Just go down. Okay. So there is no column name called unit space price. The column name is unit dot price. Not that. Order data new, correct? Not this. Go to the last. I mean, there is yes, horizontal bar. Yep. Profit new. Correct? Got it, right? This is how you create any new column if you want to derive from the existing data set.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
Now you have created a new column and you have done some manipulation, and all the things we have done, we have just sorted the things and we have just filtered and all the things. Now if you want to store and if you want to write it to your local machine, in your local machine you don't have this data set, right? This data set is not there. You have just performed this in R. Now you want to send this data set to someone. Now I have created a total sales which is present in R. This CSV file or this data set is not there in my local machine. If I want to send this manipulated data to someone, I have to first export this from R, right? You guys know how to import data set from external using read.csv. Now, if you want to export this to your local machine, you have write.csv. You give write.csv and your table name, whatever table you want to save. You want to save this or this, anything. I'm just taking this, comma. By what name it should save? Give the name. It will save the using the name whatever you mention here. So once you run this, control enter, it got saved where you're working currently. This file is saved where you're working currently. So how to know the current directory? I have shown you. Get CWD will help us to know the working current directory. So there the file will be saved. Just try it and let me know.
If you are saving the file on your local machine, will it be like, for example, if I'm sending it to someone, does the person have to open it in R or probably in Excel format or
Excel? That will open in Excel.
Okay, cool.
It's their thing whether they want to open it in R or Excel. If they want to again open it in R, they'll do read.csv. Yep, this will go and save in a current working directory. On which directory you're working, open that file, that directory, there you will find that.
Okay, where I imported the data set from?
No. I'll just telling you. So my current working directory is I want to see my current directory, get WD, control enter. So right now I am working in this directory. So the file will be saved in this directory. So I'll just have executed this code also. So I'm just going to that order underscore data underscore 1. You can see the time is 18/1/2020, 2031, and here it is 2035. It's been now 4 minutes. I have run this code, so it got saved here, order underscore data underscore 1. So just let me know once you guys save this file.
If you want to do, you start by saying other data right equals.
That you can give any name, whatever you want. I have just given order data 1. The formula is write.csv is the method. This is your table. Which table you want? Whether you want this table name. This is your table name, and with what that has to be saved on your local machine. With what name it should save on your local machine. You're giving that name here. .csv. This is the formula. What you want to save, with what name you want to save on your local machine. And this will be saved in a current working directory. So guys, waiting for you guys to complete it. Once it is done, I'll just move to the next topic. So now, whatever operations we have did so far is for only one table. So this table, right? The only one CSV file. And you remember, we have imported another CSV also. In real time, you will not get only one data file to work on. You will get a multiple data sets. So if you are getting a data set of 60 columns, 20 columns would be in one CSV file, 20 would be in another CSV file, and another 20 would be in another CSV file. In that case, you have to join those data set. You have to merge those data set. How will you merge it? So to do join, you have multiple types or multiple joins. So first is an inner join. You can do inner join on any two tables, or you can do inner join. Left join is there. Outer join. Right join. Full join. So these are all the main forms of joins, important forms of joins. So what is an inner join? Assume this is your left table and this is your right table. A is your left table and B is your another file. A is one file, B is another file. So what inner join does is it does join which has only common in both the table. For example, I'm giving you an example. So first make a note when joins can be done. Joins can be done, or you can merge two tables if and only if you have a unique column present in both the tables. For example, now here I have customer ID and I have sales in one table. Customer ID is 1, 2, 3. Sale, he made it for me is $50, $60, and $70. This is my table 1. And I have another table where it has cust ID, and there I'm having his name. Cust ID is 2, 3, 4, and name is A, B, C. So in this table, I have only sales, and in this table, I have name. So first, I want to join these two tables. So again, to join any two tables, first criteria is there should be a unique column present in each table, in both of the tables. Here, so here I have cust ID, which is a unique column present in both the table, so that I can do join on these columns. So if I do inner join, it will give me the output whichever values are same in both the tables. So here my output would be, if I do inner join, my output would be 2, 3, 50, no, he had made $60, $70, and the name is AB. I don't get this data as well as this data because only these are intersecting on both the tables. This is what the inner join is. Left join, complete left table you will get. Right join is complete right table you will get. Only left is this moon shape you will get. So whatever column intersection also will be deleted. Only right is also there. This only right column will be. So these are all the types of join. Again, you will learn joins in detail when you are learning an SQL topic. There in detail you will learn. Here you should know what is inner join, what is left join, outer join, and all those things.
What outer join looks like? You saw inner join for left join and right join. From the table, what should be outer join?
Yes, outer join will look this.
Got you, thank you.
Okay. So can anyone tell me what will be the output of outer join? Cust ID I have 1, 2, 3, and sales I have 50, 60, 70, and another table I have cust ID I have 2, 3, and I have name which is A, B. Now, okay, 2, 3, 4, and C. Okay. So if I do an outer join, if I perform outer join on these two tables, what output you are expecting?
1 and 4.
Perfect.
1 and 4.
Correct.
1 and 4.
The output would be 1, 4, 50, null, C. Perfect. Correct.
Yeah, correct. Thank you.
Perfect. So this is how you can. So try out with multiple joins. You will understand. So now you got to know what joins are. Just go once you finish with this session, just go and explore. You'll get a lot of things. So now if I want to do joins, so you can see, I'm just clearing it everything. Here you can see in the first table, I have these many columns. And in the second table, I have only 2 columns. First column is an order ID. Again, you can see in both the table, I have a unique column that is an order ID. And I have a status here. I want to merge these 2 tables. How will you do it? So for that, you have a method called merge. So whatever you mention first will be your left table. Whatever you mention second is your right table. First parameter is your left table. Second parameter is your right table. So merge left table, right table on which you want to merge it. So in left table, you have name called order ID. On right table, you also have a name called order ID. So if you do this, the inner join, by default, if you don't mention anything, it does an inner join. So why this is important is, sometimes in the left table, the name would be order ID. In the second table, the name would be order.id. Even while I have given you the example, in the first table, it is customer ID. In the second table, it is, instead of customer, it is user ID. Actually, both are same. Both columns are representing the same thing. So I am doing join on these 2 tables, user ID and customer ID. In that case, here you will mention customer ID and here you will mention user ID. Simple. That is the reason this parameter is given. Perfect. So just perform an inner join, and there is an assignment you guys to do outer join, left join and right join. I'm just showing you an inner join. That's it. For outer join, there is another parameter. For inner left join, there is another parameter. Only just one parameter will do so. So I want you guys to perform left join, right join and an outer join. 3 joins you have to do it from your end. Here I'm just showing you the inner join. Because if I spoon feed everything, I'm sure you guys don't learn anything from your end. So I want you guys to perform 3 extra joins. Even there also, see, here only you can see the code. For left join, even you are using merge. Only I'll just glance it. I'm using another parameter, that's it. Just Google it and try to do it left join, right join and outer join. Make a note of these 3. Okay. So guys, just let me know once inner join is done. Okay. So now you guys know how to merge any 2 data sets. Next, if you want to find any null values present in your data set, this is how you can do it. Is.na will help you to find out the null values. Okay, see,
capital O.
No. Okay, not capital O. The error is status data not found. That means you have, see, your status data you have imported, yes, is small over there. Here you have given a capital letter. Just guys, make sure that this R is a case sensitive. Yes, perfect. Got the output. Just slide it and got joined. Okay, perfect. So next, if you want to find a null values present in the data set, again, you can find out with a summary as well. Summary will help us to find out the null values. I have told you in the second session. You remember it, guys. You remember that concept, right? Summary, univariate analysis. So there also you will get to know how many null values are there in a particular column. Even there is another method to find out is NA. Is.NA will help us to find out this is, I'm giving a complete table. You can give column names as well. Sales. See, false means there are no null values present in a column sales. Is.NA will help us to find out the null values present in the whole table as well as in any one particular column, in any column. Next, you can give order priority, anything, whatever you want. You can find out the null values. In total table, we have 63 null values present. Just find out the null values.
Profile only on the sales column, it is giving, false 8399. What does
Correct.
it mean? There are no null values?
Correct, exactly. There are no null values in that particular column. You try within any other column. So even when you do, okay, I'll just show you it once again. So assume now, okay, fine. I'll do univariate analysis. That is what the summary does. Summary of this order data. Control B, Control Enter. So what will be the output of the summary? If at all it's a categorical variable, it gives you the count of the categories present in that particular variable. Correct? If at all it is a numerical value, it gives you a mean, first quartile value, second quartile value, what is the minimum value present in the data set, what is the maximum value present in that column, sorry, not data set, in that column. So that will be the output. That is what the univariate analysis is. So leave out this order ID, row ID, that is not at all, date is also not at all useful. So the next column is an order priority. So in order priority is a categorical variable. So this tells me how many critical values are present in this data set. So what is the count of high priority? What is the count of low priority? What is the count of medium priority? What is the count of not specified categories? So it gives the count of each category if at all the variable is categorical. If it is continuous, order quantity is a continuous value. It gives you the minimum value and the maximum value, mean value, everything. Sales, ship mode is this. So here, again, you can see, yes, in product based margin, you have 63 null values, NAs. So in total table, you have 63 null values, and all the 63 null values are present in only one column, that is product based margin. Correct? So that is a method to see also, and even in summary, you will get to know everything. In a univariate analysis, you will get to know. So guys, any doubts? So now I'm giving you 10 minutes. Now I want you guys to perform left join and right join and outer join right away. So once you complete this is.NA, try doing left join, right join, and outer join. So I want Inner join you have done. Inner join is done. I want left join for that particular, those two table. Right join I want outer join. Inner join is done, correct. It's done. I want these three joins, left join, right join, and outer join. Google it and let me know. Even I'll tell how to Google also. Left join in R. You will get a code, try to execute it. So just ping me once it is done. I want left join, right join, and outer join. All the three outputs.
Yeah, I got. Does the one we had, the table into bracket S I has
Correct.
is not a.
Correct. This one.
What does that do exactly? I'm sorry.
That will find out how many null values are present in your data set. Blank values.
I understand, but does it have any effect on the inner join, left join, or is different?
No. That is not benefit. That is altogether a different story. That is altogether a different concept.
I understand. I was thinking like because you said
no. That is altogether a different concept.
Gotcha.
Okay. Perfect. So now you guys are clear. Know what you have to do it. You have to perform left join, right join, and outer join, and just get me the output.
Please, on which data? Is it on the same order.id or on different data?
Yes. Again. Join has to be done only on these two, right? And these two table, the same table and the same column, everything same. I just want outer join output, left join output, and right join output. Simple.
Yeah. Left outer join, I think, giving the satisfactory results, but for right outer, actually, I'm just seeing more.
No. Don't do. Correctly. Don't do right outer or left outer. Do left join and right join. Only left join. Don't do outer.
For the full join, please, what's after the or? For the last code, is there what else is different? What's the
sorry
on your screen, like on this screen presently? There's a code after all, ALL, like all.
Yeah, that's what I just want you guys to perform left join.
Oh, okay.
Yeah. I just want you guys to perform left join, right join, and outer join. 3 joins.
So not full join.
No, don't need a full join. You can, if you want, you can perform that also. That's fine.
So firstly is like basically we are taking two source tables, so left table and right table by ordering the join field. And all x is equal to true, and if it is all y is equal to true, this is a right outer join because we are saying. But the results I'm not happy. But let's discuss that.
No, that's fine. The code is correct.
For full, it is saying that if you put all, it should be true. Okay, simple.
Correct. Exactly.
Okay, for the left, let me just use all these. Okay. Sorry. Ordered data. Okay, we need ordered data and status data as well. Okay, let's keep these two so that it would be. So first one is like left, right? First one left. If I click on left, the left data. Okay, this is based on the all entries from the left-hand table, and which is calculated only for matching entries from the right. The rest it is putting not applicable.
Correct.
So to validate this. Not applicable, the 65. Okay, so if we go to status data, we see 65. Starting number itself is 65. That's fine. Seems like it is working. But when I clicked on right. For the right, it is getting all the entries from the right table and matching entries. No, not like that, I think. So I see even entries from the order data left table as well. So why it's like that?
No, it's not taking from the left table.
Okay.
So you can see the right table. So how many rows are there here?
Yes, there are like 872.
Oh, where it is.
You can see here down 872.
It's 872. Correct. So how many rows are present in your status?
It is around 500 odd, actually 572.
Okay.
Yeah, I see duplicates actually. Say for example 7. I did a coding as well for 710. 1 second, just to retrieve the result. Test. Okay.
Perfect.
Where is the test? Yeah, I see with 7110 there is only one entry. Okay. So when I see right now we are analyzing the right. So
Okay.
710.
710.
Yeah, I see.
Oh.
You see multiple values actually.
Multiple. Correct.
Yeah. Why
Yep, correct.
that way?
So yep. So here the data set is not proper.
Okay.
So with one order ID, there are multiple orders here.
Yes.
Even you can see 710. First he has ordered 11, 29, and 42. No, actually it is like transaction level. It's not customer level.
Okay.
The data is of transaction level.
Okay, we can do this way, right? 7110. Okay, if I say, let's put it this way, like test one. Sorry. Test one is equal to. Again, I copy the same text.
Okay.
Filter, like instead of order data status.
Okay. You do order data. Perfect.
What we have. The test one. Yeah, there are 3 entries. Yeah, 3 entries. So the tree is getting matching 3.
Yes, it was getting matching 3. So there I have only one 710 order, and for all it is taking return.
Okay. Yeah.
Getting that is then inference. Correct. That's fine.
Okay. Results are okay then.
Yep. Awesome.
Right is done, but yeah, full I didn't validate anything.
Yeah, that's fine. So the codes are correct. That should be fine. So obviously everything will be joined. Some of will be null and some of will be returned. That's correct. So just show me the code.
Okay, the code is left.
Okay, left join is a merge join. No, it's not a left join.
That's not a left join.
No, it's not a left join.
What about the right and the outer?
No.
And the...
Even it's okay. So outer out, whatever name you have given, that is your right join. Yep, and the down one, full out, what you have given, that is your full join. Yes, and if you want left join, the changes you have to make is in the outer out, whatever you have given, all dot y is equal to true. Instead of that, you have to give all dot x is equal to true. That will be your left join. Not that. Outer out. Last second. Yep, there, outer out.
It was not coming, so I had to change it.
Yes, that one only. That's down one. All dot x, all dot. Instead of all dot y, just give all dot x. That will be your left join. Perfect. Awesome. You have done outer join. Not outer join. You have done full join. You have done right join, and you have performed a left join. Perfect.
So the left join is supposed to be x, not y.
No, that is fine. After that, you have to give another parameter there. So just neglect those codes. Just concentrate on last 2 codes. Yeah, those 2 are correct. First one is right join, and second one is full join. If you want to perform left join, instead of all dot y, make it as all dot x. Yep. Other 2 are correct. Last 2 are correct. You got it, right? I got. Perfect. So in today's session, we have discussed all the functions of dplyr package. So the very first, we have seen how a particular or a required column can be extracted from the data set using a select option or a select method. Next, we have did a subset to filter out the rows. And you have another alternative method to do it, that is a filter option again. And after that, we have seen how to sort the columns. And after that, no, it's not correct actually. This will do you not outer join, it will do you an inner join. How you got to know that this last one will perform an outer join? That's not right. Okay, fine, I'll just come back to you. I'm just summarizing things. Next, we have seen, once you know how to sort the data, next we have seen how to, if you want to create an extra variable, if you want to derive one variable, then you use mutate function. Next, you see, and you also know how to save a CSV file, how to export CSV file. Next, we have seen how to do merge, how to join two tables. And next, we have seen how to find out the null values present in R. So these are all the topics we have covered in today's session. So coming back to this chat, this question, this answers, left join is not right, right join is also not right, outer join is also not right. So the left join would be merge order data, the status data is a second table, by.x is equal to order ID, comma, by.y is equal to order ID, comma, all.x is equal to true will be your left join. Next, all.y is equal to true will be your right join. All is equal to true will be your full join.
Quick question. What you're saying is for the C into bracket, it's not there. Like
No, just don't concentrate on this code. So whatever, so I just want Srinivas to paste the code. He has done it. Here both are actually full join here. If you want left join here, it should be all.x. Here what we have done is for left join, so this is your left table, this is your right table, and by order ID, how you're joining on order ID, and all.x is true. That means left table, x table, this is true, that means it's a left join. If all.y is true, then it's a right join. So why does, so that is what that means. This x table, from x table I am keeping every value. This x, all.x helps us to know from which table I have to keep everything. If you keep all.x, that means from x table, what all values are present, everything will be taken. If you give all.y, all the values from right table will be taken, so that is your right join. All is equal to true means from x and y, both you're taking, so it is a full join.
Can you do away with the x equals order underscore data, then the y?
No, the by.x will help me to know on which variable I have to join. So I was giving you an example, right? I have two tables. One is cust ID, and I have another column, it is sales, and another table I have cust ID, and I have name. So here, if I have two tables, this is A table and this is B table, if I want to join, on which column you are joining? I am joining it on customer ID, which is present in both the tables. So that is this. So that is this order ID is. that is customer ID. Clear? On which you're joining, that column is order ID.
The first one, I say left, okay, in my formula, like we are putting that X and Y and all, and this is like in the join standard like we follow normally, okay? So
Correct.
the code, we don't have to repeat all dot order data. So what I'm asking you, say I pulled off no X, no Y, okay? Simply I put order data, comma status data, by is equal to order ID, comma, instead of all dot X, okay, directly I put the table name order data is equal to true. Do you think that would work?
That will not work.
It's not work. So it's a syntax we need to follow actually.
Yes, it is a syntax. All dot X is a parameter that you have to give it. No, that will not work.
What I'm saying, because I don't keep say all dot instead of all dot X, all dot order data. I give the table name directly.
All dot order data is equal to true would help. Yes, correct. So yes, again.
Yeah.
This all what you have to just try it out once.
Yeah, sure.
So just to try it out everything, tomorrow we'll have a detailed discussion on this.
Sure.
Here. So just have a look on all the codes. Wherever you stuck, wherever you have doubts, just make a note of it. Tomorrow first we'll discuss all the doubts and then we'll move on to the future topics.
Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website.
The complete deployer package. In that deployer package, we have seen how to select our required columns from the dataset using a select function. And we have seen how to filter the dataset using a subset function. Or alternative option you can use a filter method as well to filter the dataset. Again, in filter or in subset method, you can give multiple conditions. And the next we have seen how to sort the dataset using an arrange function. Using an arrange method, you can sort out the data. Next, we have seen how to create a new variables using a mutate function. Mutate function will help us to create a new variable. If you want to derive a variable, then you use a mutate method. Next, we have seen how to save the file. Now you have manipulated and you have created and you have changed the table and you want to save that file. So for that, write.csv would help us. And next, we have seen how to merge two data sets. In real time, we don't get data in each single file. There will be multiple of data sets. So for that, we have to join it. So according to the business, it's up to us whether it can be done inner join, left join, outer join, right join, full join. It's up to us again. What is the use for the business? Based on that, we have to perform a join. And next, we have seen how to find out the null values present in the data set. Right? And in today's session, we'll see the visualization part. How do we visualize in R? Now, for example, you have a data set and you want to plot, you want to see it visually using a bar plot or a pie chart, etc., etc. So for that, first I am creating a vector called slices, and I am creating another vector labels. In that, I have values like US, UK, Germany, and France, so on. So to create a pie chart, there is a method called pie, and here is your X value, and here is your labels is your Y value. And here I am giving a heading as pie chart of the countries. So as in the first session, I have told you that visualization output will be seen in a fourth window. So once I run this code, first I'll be running this, next I'll be running this, I'll create a pie chart. So here you can see a pie chart of countries. So again, for a presentation, for a client presentation, we never perform any, we never take images of this at all. We just export this, perform this in Excel or do it in Python. So that's a better visualization. Just you should know how to create a pie chart in R. So guys, just let me know once you guys complete this pie chart. So in that case, I'll send you the code, just copy paste and run it. Instead of wasting time in writing the code, just copy paste it. So this is how you create a pie chart in R using a pie method or a function. Hey, I'm just doing it right away. I have seen the deployer package, the complete deployer package, right? So today we are seeing how to visualize in R. So now you want to visualize it, like you have a column and you want to see the distribution in a bar or a pie chart, something like that. So how to build that, how to plot graphs, how to visualize things in R. I was just teaching, and just now we have done a pie chart implementation. So next is a bar plot. So next what I'm doing is, so empty cars is a table wherein it's an inbuilt data set in R. Empty cars is an inbuilt data set which is present in R. So using that inbuilt data set, I am taking a gear variable and I am plotting a bar plot on that. So first what I'm doing, I'm just creating a table of empty cars of gear. Next, I'm plotting a bar plot. Bar plot, this counts is a variable, and heading, what should be the heading? Car distribution. And what should be on x-axis? On x-axis, there should be a number of gears. So once I run this, you will see the output of bar plot. So again, this visualization is not at all perfect or not at all good. So we don't visualize anything in R. But you should know how to perform things in R. That is the reason I'm showing it to you. All the things you have to do it in Python. In future, you will be learning Python. Their visualization is awesome. You will get all things in colored format. But you should know how to plot the things. So I'm just showing it to you. Cool. This is how we perform a bar plot.
You need to do some importation or like from library, or you don't need to do any library importation.
No, nothing.
Plots, bar plots into bracket counts, main, you execute before you do the XLab.
So this is, I'm just creating a table. This empty car is an inbuilt data set which is present in R. In this table, I have a column called gear. On that particular column, I am plotting a bar plot. In that column, you can see 3, 4, 5 are my categorical variables, values. And I am plotting a graph on that particular column. So using a bar plot function, define the first parameter would be your variable, that is your counts. the table, whatever you have created here, is your first parameter. And this is just you're giving a heading to that particular chart, telling it's a car distribution. And you're giving X slab is a label for the X-axis. So X slab is equal to number of gears. That gives you label to the X-axis. Next is a box plot. So you guys know why the box plot is used. Box plot is used to find out the outliers present in that particular variable. And you also know what do you mean by outliers. We have studied it in statistics. What are outliers? You know, to find out those outliers, we use box plot. With the help of box plot, we get to know there are any outliers present in the data set or not. How? Above 95 percentile, we take it as a outlier, or 97 you can make it as, and below 3 percentile we treat those values are the box plot, outliers, sorry. So if I run this is my box plot. This is how a box plot looks. And the next concept is a scatter plot. If you want to plot a scatter plot, you have a method called plot. Plot will help us to see how data is there in the data set. So now give a second. PL40. Okay, this is a plot, correct? So if I run this, you can see I get a scatter plot. It is used for finding an outliers present in data set. And you know what do you mean by outliers? We have studied this in statistics, right?
Yes, but I cannot see from that one where the outlier or something like that. So that's why I was asking.
Okay, so I'm just zooming in. So here I cannot zoom in and show it to you. So by this box plot, you will get to know for this particular variable, 4 variable. So I have one value, right? One variable, that is 4. Here, I'll get to know what is my 75th percentile, what is my 25th percentile. Okay. Same way, you'll get to know what is your 97th percentile value. You will get one value, that is, for example, 48 is your 97th percentile. That means above 48, what all values are present in your data set, you will treat it as an outliers. So right now, you just concentrate on how to plot it. How to plot the box plot, that is box plot. How to apply and all those things we'll learn while we are building a model. So right now, just focus it on functions. What all functions are used to build graphs? Box plot function is used to build a box plot. Plot is used to build a scatter plot. Bar plot, bar chart. Pie for pie chart. This should be clear. That's it. Okay. So, and next, can anyone tell me what method we use to find out or to perform an univariate analysis? What method we used to perform a univariate analysis?
All right, let's test your knowledge. Here's a question for you. Which of the following is not a common step in the data science workflow? Option A, data collection. Option B, data pre-processing. Option C, model deployment. Option D, data encryption. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comments section. Hey there, want to get good at data science? Our Data Science Master Training course is here to help. You can take it at your own pace on our platform. In this course, you will learn all about data science. It's like a toolbox for analyzing data, from understanding trends to making predictions. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they are talking about. Your teachers are pros who have been doing this for ages. They are here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is affordable. Ready to become a data science pro? Sign up on our page now. For more info, check out ZaranTech's website,